நான் சாப்பிட்டுட்டேன். எடுத்துருங்க. சாப்பிடுறீங்க. ஆமா.
Sir, may I audible, sir? No, sir.
Getting for you? You are not getting my voice? Yes.
Good morning, sir. Dr. Loganathan, sir. May I audible?
Yes.
Sir, you are audible. Am I audible to you?
Yes, sir. Shall we start, sir?
In the name of Allah, most gracious and most merciful. May the peace and blessings of Almighty be upon all of us.
Volume correct. Volume.
Good morning to all esteemed guests, respected professors, eminent speakers, researchers, and delegates. As we begin today's gatherings, let me start with a thought. A conference is not just an event. Conference is not just an event, it's a meeting of minds, a space where ideas take shape, grow wings, and become solutions. With this spirit, it's my great honor to welcome you all to the 10th International Conference on Recent Advance in Chemical and Environmental Research. This year is especially meaningful for us because we have stepped into the 75th year, a glorious journey of learning, research, and academic excellence. On behalf of the organizing committee, we extend our warmest welcome to every participant who has joined us to share knowledge, inspire innovations, and contribute to global scientific progress. Let us begin this program by invoking the blessings of Almighty. May I now invite Dr. A. Asrar Ahmed, Assistant Professor, Department of Chemistry, to recite a few verses of Holy Quran. I welcome you, sir.
أعوذ بالله من الشيطان الرجيم بسم الله الرحمن الرحيم قل هو الله أحد الله الصمد لم يلد ولم يولد ولم يكن له كفوا أحد صدق الله العظيم.
Thank you, sir. Small cheer and great welcome makes a merry feast. With immense respect, I now request our beloved head of the department, Dr. A. Jafar Ahmed, the true backbone of our department, to welcome the gatherings. I welcome you, sir.
A very pleasant good morning to one and all gathered here in this online portal in the inauguration ceremony of our two-day international conference, ICRacer 2000. ICRacer 2025. Of course, I'm very much delighted and indeed very happy to welcome one and all gathered here for all a part of this event. This year, the citadel of education, science, arts, and everything, of course. The great Jamal Muhammad College, various countries throughout the globe, across the country also. In this August juncture, I would like to welcome one and all gathered here to witness and to present their findings as international conference. I'm happy to thank our management committee members, our beloved respected secretary and correspondent, respected treasurer, respected assistant secretary, members, and our most beloved principal for having given permission to conduct or organize this international conference in a different way, that is one day on online mode, to facilitate, to participate the to facilitate the participation from across the globe in the conference. I'm really extremely happy and thankful to all the participants from across the globe and across the country who contributed to this conference in the form of their research findings. I'm very happy to welcome the chief guest of today's event, Professor Mayakannan Gobiraman. Thank you very much, sir, for accepting our invitation to go over here to sorry for the trouble. So I'm very happy to welcome Dr. Mayakrishnan Gopiraman, who is an associate professor in the Division of Molecules and Polymers, Institute for Fiber Engineering and Sciences, IFES, National University Corporation, Shinshu University, Nagano, Japan. Sir, we are very much grateful to you for accepting our invitation to inaugurate the function and deliver a keynote address in this August event. Really,
thank you very much, sir. It's my pleasure.
We are very much thankful to you. And as we had a conversation yesterday, we'll be very much pleased to have you in our campus one day. So whenever there is a time we find, we will be pleased to invite you to our campus, because this campus is celebrating its platinum jubilee in this year. Of course, it is a very great place of learning, exploring the knowledge, for making the young minds to become leading researchers. Okay, so at this juncture, I'm very happy to welcome you, sir, to this international conference, which has been arranged today purely online mode. And of course, we are going to have the international conference tomorrow as the regular way. So in this August juncture, I'm very happy to welcome all the participants from across the globe and across the country who have contributed their research findings to be presented, followed by the keynote address of Professor Gopi Raman. I welcome all my fellow colleagues, student friends who joined in this Zoom meet. Once again, I'm very thankful to the organizers. And of course, I have to thank the organizing committee members and the organizing secretary, Dr. S.S. Syed Abu Tahir, Dr. Asrar Ahmed, and Dr. Hema Sindhuja for their strenuous effort for making this event a very great, grand success. Of course, beginning is half done. So we have begun in a well disciplined manner. Therefore, I would say that this conference is a successful one, and I request all the participants to present their findings in a lucid manner, of course, and also I request all the participants to be in the online and get benefited from the space, that is the speakers from various other places also enjoy the research findings of others also. I once again thank and welcome each and everyone to this international conference. Thank you very much.
Thank you, sir. We have dynamic faculty member with us, Master of Group Theory, a vibrant voice of our department. With respect, I request Dr. K. Loganathan, Associate Professor of Chemistry, to introduce the resource persons. I welcome you, sir.
Honorable Secretary and Correspondent, esteemed Treasurer, respected Principal, distinguished Directors, beloved Head of the Department, respected faculty members, dear research scholars, students, delegates from other institutions who have joined us online, a very warm good morning. It's my great pleasure and honor to introduce the resource person of this inauguration session of the 10th International Conference on Recent Advances in Chemical and Environmental Research, ICRACER 2025. Our distinguished speaker today is Dr. Mayakrishnan Gopi Raman, Associate Professor at the Institute for Fiber Engineering, Research Cluster for Social Implementation, National University Corporation, Shinshu University, Japan. He is a renowned scientist and academician whose research covers materials chemistry, heterogeneous catalysis, electrospun nanofibers, carbon nanocomposites, corrosion science, energy and environmental applications. Dr. Gopi Raman earned his master's degree in chemistry from the National Institute of Technology, Tiruchirappalli, and subsequently completed his PhD at Shinshu University, Japan. His academic career includes significant appointments in Japan, South Korea, and India, notably as Associate Professor at Konkuk University, Seoul, and as Distinguished Adjutant Faculty at Savitha Institute of Medical and Technical Sciences, Tamil Nadu. His research achievements are remarkable, with 121 publications, more than 4,980 citations, an H-index of 41, 16 patents, and several major projects. He also serves as editor-in-chief of the journal Nanoscale Reports. He is also on the editorial board of many international journals and has reviewed for over 100 reputed journals, including those of American Chemical Society, Royal Society of Chemistry, Elsewhere, Wiley, Springer, and Nature Publishing Group. Dr. Gopi Raman has received several honors such as the Best Oral Presentation Award at Shinshu University, Japan, and also received poster awards in the year 2024 and prestigious Japanese government mixed scholarship. His team's pioneering work during the COVID-19 pandemic, that is developing PU nanofiber composite mask, gained wide recognition and was featured by NHK Japan and other media outlets. He is also a well-known speaker who has delivered keynote and invited talks at major conferences and institutions in China, India, Japan, and South Korea. With his expertise, innovative research, and dedication to advancing chemical and environmental sciences, Dr. Gopi Raman stands as an inspiration to both young researchers and experienced academicians. With this introduction, I humbly request Dr. Gopi Raman to enlighten us with his lecture on advances in electrospinning from nanofiber fabrication to functional application. Thank you. Thank you, sir.
Thank you, Professor Dr. Loganathan. Can I share my slides?
ಆಡಿಯೋ ಅವ್ರದ್ದು ವರ್ದ ನಮಗೆ ಅವ್ರು ಆಡಿಯೋ
Sir, your screen is visible, sir. Kindly proceed.
Okay. Okay, thank you. Good morning, everyone. First of all, I thank Professor Dr. K. Loganathan for his very kind introduction. Also, I would like to express my sincere thanks to the organizer and the organizing committee for inviting me to speak at this 10th International Conference on recent advances in chemical and environmental research. It is truly an honor for me, so special thanks for that. So today, title of my talk is Advances in Electrospinning from Nanofiber Fabrication to Functional Applications. In this talk, I will share some of my recent research results, progress from the Institute of Fiber Engineering and Science in University, that focusing on the development of nanofibers and its application in various fields. I don't know how many of you are very familiar with the electrospinning and nanofibers, but I hope today in this presentation you can have some basic idea on what is electrospinning, what is electrospun nanofibers. So you will have some basic idea, I hope. So from this slide, I will turn off my video so that we can focus on slides fully. So thanks for the understanding. So this is the outline of my today's talk. First, I will give a very brief introduction about Shinshu University, just to set the background of where our research is based on. And next, I will move into electrospinning part, what exactly it is, and how the process works, and how we prepare the nanofiber, different types of nanofibers. So I will keep very simple, and I will show videos on the electrospinning process so that you can easily follow it. After that, I will discuss the potential applications of nanofibers. Then I will touch on some several areas like catalysis, energy storage, environmental remediations, and also biomedical uses, so that you can understand how important the nanofibers are. And later I will also touch briefly on the overall scope and future opportunities in the nanofiber research. And finally, I will introduce a few nanofiber-based commercial products that were developed in our laboratory, demonstrating how the research translates into real-world applications. So that's the plan for today, and I hope it will give you some simple overview of the electrospinning field. So to begin, let me briefly introduce where our university is located. Actually, Japan has 4 main islands. One is Hokkaido, Honshu, Shikoku, and Kyushu. Since university is located in Nagano Prefecture, right in the center of Honshu, it may take, if you take a bullet train from Tokyo, it will take 90 minutes to reach our campus. So it is quite, you can say it is a very accessible place from Tokyo, main city of Japan. And Nagano is very famous for its mountains. Out of 21 mountains in Japan that are over 3,000 meters, almost half of the mountains are in Nagano prefecture. And this place is very famous for its snow, ski, and hot spring. So people often call it as a hot spring paradise. Actually, this place is famous for after hosting Winter Olympics, 1998 Winter Olympics. So if you ever get chance to visit Japan, I highly recommend you to visit Nagano Prefecture. It's worth visiting it. And this is a history of my institution, particularly my campus. Our university has 5 campuses with 8 faculties across 4 different cities. The main campus is in Nagano. Main campus is Nagano, and Nagano actually it focus on I'm sorry. Yes, this is yes, we have 5 campuses. Nagano campus focuses on arts, economic, science, and medicine. Matsumoto campus is dedicated for education and engineering. Minami and Ina campus is for agriculture and biomedical. Our campus is focused mainly for textile and technology. Here you can see the panoramic view of our faculty. It is not a very large campus, but it is very specialized and extremely active in research. We have approximately 1,250 students, both undergraduate and graduate students, and around 250 staff members in our campus. So you can say our faculty is very compact and everything is well organized for especially for the fiber research, silk fiber research. This is the history of our institution, a very brief history. Our campus has very long and unique history. It started as an imperial institution, university in 1910, with a primary focus on silk. Later in 1944, we expanded into polymer chemistry, chemical fiber, spinning, dyeing, and many other textile-related fields. Over time, the institution evolved, and in 1949, it received its current name, Faculty of Textile Science and Technology. And we can say today we have around 115 years of history. And some interesting thing is Japan has nearly 800 universities, national and private universities, and about 2,600 faculties. But ours is the only textile focused university in our country. So it is, you can say it is quite a special and unique place. So in our campus currently we have 4 departments and 6 research institutions. And these departments revolve around the central theme, fiber. Textile science is actually very interdisciplinary. It does not stop with engineering. It also includes science, agriculture, even biomedical field. And we call it as an comprehensive form of engineering field. I am part of IFES, Institute of Fiber Engineering and Science, and my research is focused on polymer nanofibers for catalysis and energy application. At present, since university, we actively collaborating with the institutions around the world. Right now, we have more than 100 MOUs with international universities and research organizations. Recently, we established MOU with IIT Delhi and CSIR Ampril Bhopal. And currently, we are also working towards collaboration with NIT Trichy and IIT Madras. And of course, I believe that having a MOU with the Jamal Muhammad College would be very beneficial, especially for student exchange and joint research. I hope we can move towards this in the near future. I have a video on Cincy University introduction that I will play it at the end of this presentation. So here I will start introducing what is nanofiber and what is electrospinning, what exactly it means. It's extremely small. When you compare human hair, the size is around 100 micrometer. But when you compare nanofiber, it is 100 times smaller than the human hair. So you can imagine how small it is. In nanoscience, we can call under 100 nanometer, we can call it is nanomaterials. But in textile fabric industry, from 50 nanometer to 2000 nanometer can be called as a nanofiber. And this nanofiber can be made from polymers. You can use metals, ceramics, you can make to fabricate the nanofiber. There are several methods to fabricate the nanofiber. You can call melt blowing method, self-assembly method, template-based synthesis, hand spinning process that we invented, and electrospinning method. Our interest is electrospinning method. In fact, it is very simple and highly versatile, the low cost method. And recently there are many mass production advantage. It is highly advantage of mass production, and it has a very less pollution in environmental impact. So electrospinning is our interest of research. What electrospinning it is? It is a simple technique that uses high voltage to pull the polymer solution into ultra-fine fibers through a small opening called spinneret. Here you can see this is the spinneret and this is the polymer solution. When you apply high voltage, the polymer solution is, you can say, it pull into your ultra-fine fibers. So actually these fibers are lightweight and has a very high surface area. When you consider pores, it is highly porous, and you can control the pore structures as well. And mechanical strength is also very good, so that you can go for various applications. It is highly flexible. Unlike other nanomaterials in the form of membrane, the nanofibers are highly flexible, and very important thing is very easy to handle. Very easy to handle. So these are the advantages of nanofiber. So before I go into detail, I will give you some history of electrospinning. Actually, in 1914, Professor Jeleny, he is the first person to observe the spinning behavior of conductive polymer solution under electric field. Then later in 1934, Professor Farmhouse, and he is the first person to patent on experimental production of nanofibers. Then later, 1966, Professor Simmons, he patented an instrument for fabrication of ultra thin and ultra light nanofiber fabrics with various patterns. Then 1967, Professor Tyler, and 1971, Professor Peter, they also have dedicated to improve the spinning techniques. Then later, Professor Rienecker, Professor Iksu, Professor Lando, and Professor John from Technical University of Libres, they had a remarkable dedication on the nanofiber to take the material into the next generation level, so that now the nanofibers are realized as a potential material in various fields. Here you can see the schematic of the electrospinning setup. Here four important parts you have to look. First, the power supply, and then the electrode, polymer container, and then rotating collector. These are four very important parts. And here I show how the fibers are forming. This is the polymer container, and here we are applying high voltage so that you can see the polymer, the nanofibers. Actually, the mechanism is when you apply high voltage, when you apply high voltage, sufficient high voltage to the polymer solution gets charged, and the electrostatic repulsion counteracts the surface tension, and the polymer solution at the tip can be stretched. At a critical point, the polymer solution erupts from the surface, and that eruption point is known as Taylor cone, and further ejects into nanofiber, very fine nanofibers, and which after stretching it, the solvent evaporates, eventually depositing on solid nanofiber onto the collector, forming you can see here, after collecting the nanofiber, after 5 to 10 hours, you can get nanofiber mats like this. And here you can see how the fibers are forming at under high voltage. So I guess this is a PU polymer solution. It is very smooth electrospinning. Here I can show the laboratory scale electrospinning machine. As I mentioned earlier, this is the polymer container, and here we supply high voltage. When the polymer solution gets charged under the electric field, the fibers are forming very smoothly. And here is the collector. It's collecting the nanofiber. After some time, it will form like a membrane form, like here I have showed. And here you can see how the fibers are forming very smoothly. And the good thing is this is a laboratory scale, only one nozzle. In the case of a mass production, we have more than 100 nozzles, so that you can produce nanofiber. For example, in a minute, you can get 60 meters of nanofibers. So that you can say it is the mass production, because for commercialization, mass production is very important. So the nano electrospinning method is, the mass production is the very big advantage, so that it can be taken into a commercialization. And in our laboratory, we have successfully electrospun various polymer materials. Here PVA, PVP, these are water-soluble polymers. And there are some natural polymers like silk, cellulose acetate, and synthetic polymers. Various kind of polymers can be electrospun successfully. Here you can see the morphology, how fine it is. So in order to get the nanofibers in a very fine morphology and uniform morphology, you have to control the parameters like the polymer viscosity, and conductivity of the solution and the surface tension you have to tune to get such kind of unique morphology. And also you have to control the voltage. Some polymers you can say you can get fibers under 10 kilovolt, or some polymers require maybe more than 15 kilovolts. So you have to optimize the parameters like applied voltage, flow rate, concentration of the polymer, and distance between the tip to the collector, and the temperature. Even the temperature and humidity in the air, it will affect the nanofiber formation, and also the movement of the collector. Also, you should control to get the fiber. And this is the laboratory scale as I shown you the previous slide. This is our mass production machine in which we have more than 100 nozzles, so that it can produce around 60 meters per minute with maybe some particular thickness. So in the previous slide, I have shown the randomly deposited nanofiber. In addition to that, we can also produce various form of nanofiber sheets in the form of aligned nanofiber. So by just controlling the collecting rotator, you can get the aligned nanofiber, and porous nanofiber by just blending with immiscible polymers or with some active materials. With the thermal process, it can create more pores. And hollow core shell fibers can also be produced by using multi-nozzles. In the previous slide, I shown you a nozzle with only one hole. This is a multi-holes, multi-core nozzles. By using that, you can produce core shell nanofibers, twisted ribbon like a form, porous form, hollow microsphere form. And in some cases, beaded fibers are also very useful for various applications. So through electrospinning, you can not only make the nanofiber membrane in the randomly deposited fiber, but also in various form of morphology. And as you know, the polymer solutions, polymer nanofibers are mostly inert, and you have to modify it. Whether you have to go surface modification or you have to incorporate hybrid with active materials. In case of for filtration application, air filter application, or dust filter applications, even the polymeric nanofiber itself can be a good choice. But when you go for energy application or biomedical application or sensor applications, you have to modify the surface, or you have to incorporate active materials into the fibers. So this is called functionalization of nanofibers, so that it can bring suitable physical, chemical, biological characteristics to the material. The functionalization can be covalent functionalization or non-covalent functionalization, or simple incorporation or immobilization of active materials into the nanofiber, or simple grafting. After making nanofiber, you can graft with the active suitable polymer chains on the nanofiber, so that you can bring the material with high porosity, high surface area. Even sometimes you can tune the hydrophilic nature of the membrane, and also you can bring mechanical strength. The nanofibers mostly they offer very good biocompatible. So after making nanofiber, we have to functionalize them for the suitable application. So far, after there are many reports available in the literature. After functionalization, the nanofibers can be used in energy storage application, even in the battery application, catalysis application, and environmental remediation. I mean the removal of dyes and conversion of a toxic pollutant into value-added product. In biomedical application, industrial air and water filtration, even in the smart textiles, the nanofiber, the modified nanofibers can be used, and even in the agriculture, also the nanofibers are a very interesting candidate in the agriculture field. Actually, our laboratory, our backbone is nanofiber, electrospinning and nanofiber. We have 4 teams. One is a catalyst team. They focus on fabrication of catalytic nanofiber-based catalytic materials for simple catalytic organic transformations. And our energy team, they focus on flexible electrode material for energy storage application like supercapacitors, batteries. And our environmental team, they develop sustainable nanofiber membrane for adsorbent, like adsorption of organic substance from the industrial wastewater, or dye adsorption. And our biomedical team, they develop material for controlled drug release applications. So this is our team. They are focusing. I will touch one by one in very shortly and briefly. So our catalyst team, their main focus is the regenerated cellulose nanofiber based catalytic systems. Actually, nanofibers in catalytic system, we often use metal nanoparticle as a catalyst. So in catalytic application, for the nanofibers are used as a support material rather than using a catalyst itself. These are very good support materials. And most of the process, we go for non-covalent functionalization, and by using very simple chemical reduction or green synthesis method to develop the catalytic nanofiber-based catalytic system. Some of the results are published in some reputed journals like carbonaceous catalysis. So as you know, here I give some introduction on why the catalysis is, how it is important. It is highly profitable, the industry. If you consider the value of the catalytic product is 99%, then the price of the catalyst is only 1%. So that's why there are many catalytic based industries, or they focused on heterogeneous catalyst. The companies you can see, the Dalian heterogeneous catalyst, Unicat companies, they are all based on heterogeneous system. So the catalyst field is very important in industrial fine chemicals. Although the catalyst is very highly profitable, most of them are based on carbon, silica, alumina based materials. And recently carbon material is also one of the interest for developing nanocatalyst. They use graphene CNT, which are very expensive, and some catalysts are expensive or toxic sometimes. So we wanted to replace this catalytic system with nanofiber based catalytic system. So our catalyst team, they developed cellulose nanofiber based catalyst for very simple organic transformations. Here you can see cellulose has many advantages, including it is as an environmental benefit. They are derived from plant fiber, so that the production and disposal have very low environmental impact. Actually, the surface modification, unlike the carbon materials, the surface modification is very easy in the case of cellulose fiber, and it has a good mechanical property. It is highly biocompatible, and cost wise it is very low. So our team has focused on cellulose fiber as a support material for to develop the catalyst. Here we have taken cellulose acetate to produce the nanofiber. In fact, the raw cellulose is the solubility issue. It is highly insoluble in solvent. So we have taken cellulose acetate as a starting material to produce nanofiber, cellulose nanofiber. Then it was converted into cellulose fiber. Then the surface was modified with anionic, cationic charge. It depends on what application you are focusing on, so that you can bring material with high surface area with highly active sites, and those are highly thermally stable. Once after the functionalization, the fibers are thermally stable and it is efficient and stable. The very good thing is it is very easy separation from the reaction mixture. When you take a carbon materials, the separation, filtration are very difficult. But in case of nanofiber, it is extremely easy and reusable. So here is the simple process. Initially, we have taken cellulose acetate to produce a nanofiber. This is the cellulose acetate nanofiber. Then we converted it into cellulose, regenerated cellulose fiber. Then it was the negatively charged group was modified with the negatively charged surface. Then nanoparticles were decorated on the cellulose nanofiber. Here you can see, even after the surface modification, the cellulose nanofibers are intact, not damaged significantly. It is completely intact. Here the FTR result shows how successfully the cellulose converted into cellulose, cellulose acetate into cellulose, and also the functionalization of surface. So here you can see TEM image of the catalytic material. This is cellulose nanofiber coated with I think ruthenium, silver or ruthenium. And you can see how fine particles are attached on the surface of cellulose nanofiber. And you go, and it is very strong. When you compare with the carbon fibers, carbon materials, the attachments those are highly hydrophobic and the attachments are very weak. But in case of nanofibers, cellulose nanofibers especially, the attachments are very strong. So that the aggregation, you can avoid the aggregation, and it can be used for multiple times. And the loading, one of the big challenge in the nanofibers, the loading of bioactive materials are the challenging. But in case of cellulose acetate nanofiber, after functionalization, after the modification, the nanoparticles can be reached more than 10%, which is quite high, and it is beneficial for the catalytic applications. Here the XPS shows the presence of metals in metallic form, and XRD shows the crystalline form is still intact even after doping and surface functionalization. So after the testing, we have used it as a catalyst for Asamichael reaction and oxidation of benzyl alcohol. In fact, the reactions are very important in CC bond forming reactions, and also for perfume industry, the resultant product can be used in various industries. So we opted these two simple reactions to check whether our catalytic system is efficient enough to say it is a suitable material. So with mild reaction condition, the catalytic system yielded more than 99%, and selectivity is extremely very high, 100%. And similar, unlike the Asamichael reaction, the oxidation of benzyl alcohol system is also showed very good conversion with a very high selectivity. So you can say the fiber system is highly suitable for the catalytic applications. And since the oxidation of alcohol requires more than 100 degrees Celsius, the reusability was after the fourth cycle, it's quite low, but it can be overcome. And our team, they are also focusing on how to overcome these drawbacks. And in another project, we used the catalyst for reduction of nitrophenol to aminophenol. In fact, this is an important reaction in environmental chemistry. As per the US Environmental Protection Agency, the nitrophenols are highly toxic and highly stable in the soils and also wastewater. It is carcinogenic. So we designed a catalyst material to convert this nitrophenol into aminophenol in the presence of sodium borohydrate. So for that, we developed nickel cellulose-based catalyst, silver, gold cellulose-based catalyst for this system. Here you can see the nanoparticles, gold, silver, and nickel nanoparticles, how uniformly attached on the surface of the nanofiber, and the size is also very uniform. You can say it is close to 10 nanometer, 10 to under 50 nanometer, and the result shows the EDX same result shows it is very uniformly distributed on the nanofiber surface. XPS shows the presence of metals in the form of metallic form, and XRD is also confirming the presence of the metals in a nanocrystalline form. So after this testing, we opted for nitrophenol reduction. This is UV result. From this result, you can say with the time, the nanofiber-based catalyst is highly efficient to convert the nitrophenol into aminophenol. The interesting thing is, even after 10th cycle, the efficiency is it maintains its efficiency. So we can say that cellulose-based nanofiber is highly suitable for the reduction of nitrophenol to aminophenol. And in the energy team, they developed a multi-scale, multi-channel carbon nanofiber in the flexible form for a supercapacitor application. In another project, they designed some unique structure, a nanofiber with COVID-19 virus cross section like a structure for supercapacitor application, and the results are published in reputed journals. As you know, the flexible form, if you take unlike the carbon materials like a graphene CNT, the flexible form of carbon fibers, or how to say, the drawback is its low energy density and power density, and also often it demonstrates a low specific capacitance. So in order to overcome this, our team has designed multi-channel carbon nanofiber for the supercapacitor application with nitrogen doping. In fact, there are some commercially available supercapacitors. Those are all heteroatom doped, carbon-based supercapacitor with heteroatom doping. So our team, they focused on multi-channel and nitrogen doped carbon nanofiber. Usually, we use only PAN. PAN is it can give you a high yield of carbon, so it often used as a precursor for fabricating carbon nanofiber. But in our system, we took two immiscible polymers, PAN and PMMA. These are not miscible polymers, and we electrospin it. Once you electrospin it, it can form a random core shell like a fibers. And when you calcinate it, the PAN portion, the PAN portions are degraded, so that only the PMM portions are degraded, and PAN portion was converted into carbon fiber, so that it can give you a multi-channel carbon fiber. So in order to get this, we optimize the conditions like pure PAN. This is pure PAN, and this is PAN 7%, 3% PMMA with PAN 3% and PMMA 7%. At this ratio, we achieved a carbon nanofiber with multi-channel, so that the surface area is dramatically increased. So to achieve this, also we optimized the conditions like a temperature, humidity. Humidity is one of the important parameter to get the fine fibers. At the 55% humidity, flow rate is also important. TCD voltage, we optimize the condition to achieve this multi-channel carbon fiber. So this is the TEM image. You can clearly see how the multi-channels are formed. This is pure PAN, only PAN-based carbon fiber. You can see a single fiber. With the 7-3, the channels are forming. And then with the 3-7, you can clearly see the fibers with the close to 50 nanometer. In case of PAN, it is around more than 200 nanometer. With multi-channel, the fibers are under 50 nanometer. So we have taken Raman and XPS in order to confirm the how the active sites are presented in the fiber. And the Raman result shows there are defect sites which can act as active sites for the energy storage application. And the XPS shows the presence of nitrogen in the carbon fiber and also oxygen, which can enhance the supercapacitance. So here is the BET result. So after converting the nanofiber, multi-channel nanofiber, the fiber the surface area is increased. Here you can see the pure PON-based carbon fiber. It shows 352 meter square per gram. But in case of the ultrafine multi-channel carbon fiber, it increased to 467 meters square by gram. And similarly, the pore property, like pore volume, pore size also increased with respect to the ratio. And this is the XPS results. You can say nitrogen in the form of various nitrogen environment like graphitic, pyridinic, which are very helpful for the energy storage application. And here you can see even after the conversion of polymer membrane to carbon fiber, it is highly flexible. This is one of the big advantage of electrospun nanofibers. So after testing, we have checked the performance of the multi-channel carbon nanofiber. When you compare with the pure PON-based carbon fiber, it is 4.5, I think around 5 to 4 times increase of supercapacitance, which is mainly because of the multi-channel structure. So from this project, we successfully developed a multi-channel carbon fiber for supercapacitor application, but still the capacitance was not enough to say for the to the commercialization levels. So in our next current project, we are designing a carbon fiber with COVID virus like a cross section like a structure. So in which you can say this is the core and on the surface ultrafine fibers with some active compounds, also with very active heteroatoms. This project is almost completed, and we successfully developed this structure, and the results are also promising. Maybe in the near future, we will go for a patent and paper. So our environmental team, their focus is to develop PON nanofiber composite for the adsorbent applications. They use cyclodextrin materials on the cellulose nanofiber to remove the organic solvents from industrial wastewater. So this is environmental team. Their focus is on the adsorbent applications, and they have completed projects which are published in some reputed journals. So here is the introduction for why the adsorption or removal of the organic solvent from industrial wastewater is important. The reason is to fulfill the requirement of the people's requirement. Several factories are newly opened, and the 10 to 15% waste produced by industries are highly hazardous, and the increasing rate is 2 to 5% per year. So it is very, very important to develop nanomaterials to control this issue. Recently, we have carbon-based materials for the removal of such kind of hazardous materials, but we wanted to replace that. In fact, the carbon material, the production cost is high, and sometimes it has a very high environmental impact. So we wanted to replace that existing commercially available materials with nanofiber system. So we used cellulose nanofiber to replace those already existing materials. So especially to remove, toluene is also one of the industrial waste solvent which should be removed. For that, cyclodextrin is the best active material to remove the toluene. So in this project, we modified the cellulose nanofiber with the cyclodextrin molecules so that to remove toluene like hazardous chemicals. And also we developed a membrane, ion MOF-based, metal-based nanofiber membrane to remove the radioactive elements in the wastewater. So in this slide, you can see in our catalyst projects, we did the same process. And here, the cellulose acetate nanofiber to cellulose nanofiber. Then the surface was modified with cyclodextrin molecules for the adsorption of toluene solvent. Here you can see the same morphology even after several modification and treatment. The fiber morphology is completely intact without any damage or without any beads. Here you can see the deacetylation. FTR shows the deacetylation, how successfully the nanofiber, cellulose acetate nanofiber converted into cellulose fiber. And then this FTR spectra shows the successful modification of cellulose nanofiber with cyclodextrin molecule. Here the problem is we have to cross-link it with the cyclodextrin molecules. So we used citric acid as a cross-linker, and then we did cross-linking to improve the stability, because we are using it for hazardous chemical. The membrane should be stable so that after adsorption it can be easily removed from the industrial wastewater. So here you can see how the performance is. This is the pure cellulose acetate nanofiber with the modified cellulose acetate cellulose nanofiber. It shows maximum 20 to 82% of removal of toluene from the wastewater. So from the result, you can say it is the nanofiber membrane can be useful for the industrial wastewater treatment. And in another project, we designed a polyvinyl alcohol-based nanofiber embedded with ion-based MOF to remove radioactive cesium from the industrial wastewater. So here we used PVA solution mixed with the MOF, ion-based MOF. Then actually PVA is water-soluble polymer. So, and this is actually, we have to remove radioactive material from the water solution, industrial wastewater. So we have to make it stable so that it can be, it will not be soluble in wastewater. So we did a cross-linking process to stabilize the nanofiber. So here is the, under the HCl fumes, we cross-link the PVA nanofiber. Here you can see the PVA nanofiber after incorporation, still the morphology is intact and very fine fiber morphology, but you can see the color is changed. The ion-based MOF is in Prussian blue color. So you can see how the fiber membrane is showing the color, so that you can visually see the active materials are successfully incorporated into the nanofiber. And since we are going for a water filtration, water treatment, the membrane should be hydrophilic. The water contact angle shows the material is hydrophilic. And TEM images, you can see this is pure PON nanofiber without any particles. And this is the incorporated ion-based MOF incorporated nanofiber, which clearly shows the incorporation of uniform incorporation of ion-based nanoparticles. So as I said earlier, we have to cross-link it, and we did a cross-linking under HCl fumes. We use cross-linker to cross-link the PVA nanofiber. This is FTR result. It shows the successful cross-linking of nanofiber. Then after cross-linking, we used it as an adsorbent for a CCM removal. Here you can see the nanofiber mat. It absorbs CCM from the water solution. The result shows the capacity of the membrane is 91.5 milligram per gram. It is quite huge. So we can say the nanofiber is highly compatible and highly efficient for the removal of not only the industrial hazardous chemical like toluene, also the radioactive materials. So this is one of the interesting results that we obtained. And finally, the biomedical team, I will briefly introduce, give some results on what our biomedical team is doing. They use silica, porous silica, to dope drug molecules on it and immobilize with a nanofiber for a controlled drug release. So initially they took a rice hug, which is a very cost-effective material, and it can be the pores can be tuned, and it has very high OH groups on the surface. Of course, high surface area. It is highly biocompatible. The pores can also be tuned by when you go for a thermal or a chemical treatment. You can tune the pores of the silica nanoparticles. So from the rice hug, we converted this into silica nanoparticles, porous silica nanoparticles, and then we coated with the drug, alatonine drug, on the silica particles. Then we mixed with the PCl solution to form nanofiber for the controlled release of the alatonine drug. So here you can see the same images of pure PCl and also silica drug-loaded nanofibers. And when you go for the silica, the inorganic particles, maintaining the fibrous morphology, uniform fibrous morphology is highly challenging. But still, by tuning the parameters, we achieved the fiber morphology even after immobilizing the silica nanoparticles with the drug. Here you can see same image clearly. The silica nanoparticles are uniformly in the embedded in the nanofiber. So after the testing, we did the release behavior, how the drug released to the system. So this is the result. You can see with 0%, the release is how to say, release is highly controlled with the nanofiber silica drug loaded system. But in case of pure nanofiber, the release is very fast. And also with the silica drug itself, it releases drug in a very fast manner. But when you take nanofiber as a carrier with the silica drug loading, the release behavior is very controlled, which is crucial for the biomedical application and also for various other applications. So our we can say our system is highly compatible for even biomedical application. And finally, we achieved some unique morphology, honeycomb-like morphology accidentally. During electrospinning, actually, we tried to spray. In the previous slide, I showed you when you collect nanofibers on the collector, we did a green oil spray on the nanofiber mats. And surprisingly, it shows some honeycomb-like morphology, which is this is very, very interesting structure for biomedical applications. And actually, we are investigating on this. This is a FTR. The good thing is the FTR and XRD, the crystalline property and also the chemical property is still intact. By this process, the properties are not changed, but only the structure is formed very unique structure. So we are looking for some biomedical application after further studies. So at the end, this is the summary of my talk. I hope you have some idea on electrospinning technique, how it's simple and versatile, and the nanofiber can be functionalized on covalent functionalization, non-covalent functionalization. There are various methods can be opted for functionalization, and the functionalized material can be used for catalyst application, like toluene cesium adsorption from wastewater, also for biomedical uses. So it has a versatile applications. And still there are challenges we have to face and we have to overcome. The reduce the production cost is very important, and we are working on that point as well. And environmental health safety, most of the polymers require organic solvents, and particularly some polymers require toxic solvents, volatile solvents. So these are we should overcome very important points to overcome. And controlling morphology when you use different solvent mixture, that is also one of the challenging point that we have to look on it. And of course, real world applications to bridge the gap from laboratory success to commercial level. This is also highly challenging. So we are putting our effort on overcoming these challenges in the electrospinning and nanofiber field. So here some of the products we have developed in our laboratory. This is which is commercially available in the market as well. This is nanofiber based mask, nano mask, which was used by the PU polymer was used to produce this nanofiber mask, which is commercially available. And we also developed fruit bags to improve the quality of the fruits like grapes, apple. If you cover this is nanofiber based, which not only product from the insects, flies, but also improve the taste quality of the fruit. So this is also available in the market. And sanitary pads by using nanofiber, which is lightweight and with some antiseptic active chemicals. And here the air permeable nanofiber membrane, which is also commercially available. Actually this tent made up of air permeable nanofiber membrane. This membrane is it can allow only the air, not the water, so that it can be used for various applications, biomedical, in textile, agriculture. There are many potential applications for this, which is also available in the market. And currently we are focusing on developing products like nanofiber filter, air filter, water filter, and facial mask based on green nanofibers, and industrial bag filters, which can filter the VOCs, volatile organic compounds, and also toxic chemicals from the industry. So this is the end of my presentation. I wanted to show this slide for the students who are interested in doing PhD in Japan. These are the scholarship, major scholarships offered by Japanese government. Next, JSPS doctoral course fellowship, and JASO scholarship, also institutional scholarship. So you have to find professors in Japan and you have to contact them. Through them, you can apply these scholarships, and there are deadlines you can note here. If you are interested in, you can apply for this scholarship. So your CV, proposal, these are some requirements you have to fulfill. So the students who are interested in doing PhD in Japan, please you can take these links, and I will give this slide to your organizer. I think Professor Loganathan, he can contact him to get this information, or even you can contact me through email, so that we will have discussion on the scholarships. So as I said earlier, I have a video clip on Cincinnati University introduction. It's quite long, and let me play this video. Thank you very much for your kind attention. And I hope this presentation would have provided some idea on my institution and also our research area. Thank you very much.
Thank you. Thank you very much. Dear participants, if you have any clarification or doubts, kindly raise your question. Sir, shall we wind up the session, sir?
Okay. There is no question. Shall I stop sharing the screen? Am I audible? So Professor Loganathan, am I audible?
ஒரே நோட்ல இருந்து 5 டேய் முடிச்சிட்டேன்னா கட்டுடா.
Sir, Gopi sir.
Can you hear me? Am I audible?
Sir, shall we wind up?
Yeah, sure.
Sir, may I request Dr. M. Anwar Sadiq to propose a vote of thanks.
In the name of Almighty, the most beneficent and merciful, let me begin. Good afternoon and Assalamu alaikum. I am very much delighted to propose a vote of thanks for this technical session. Alhamdulillah, I sincerely convey my gratitude and thanks to our college management committee, Honorable Secretary and Correspondent sir, esteemed Treasurer sir, respected Assistant Secretary sir, and Honorary Director and the member of our college management committee, Dr. Nihal sir, for their guidance, support, encouragement, and blessings in successfully organizing this conference. Thank you, sirs. My heartfelt thanks to our respected principal sir for his constant motivation and support. Thank you, sir. I extend my special words of thanks to the head Department of Chemistry for his dynamic leadership and encouragement throughout the conference. Thank you, sir. On behalf of IC Racer 2025 Organizing Committee, I express special thanks to today's resource person, Dr. Gopi Raman from Shinshu University, Japan, for his thought-provoking, crystal clear, and energetic lecture in his field of expertise. Thank you very much, sir. I also thank Dr. Nagaswarappa, Professor of Chemistry, Davangere University, Karnataka, and Dr. Reddy, Senior Research Scientist from Canada, for their active participation and support. Thank you, sirs. My special words of appreciation goes to the entire organizing committee for their meticulous planning and hard work in conducting this IC Racer 2025. I extend my heartfelt thanks to all the delegates from various institutions, both nationally and globally, for their presence and contribution. Thank you, sirs and madams. Finally, I express special thanks to the maintenance team, electrician, sound engineers, and all the volunteers for their timely help and support in making this event a success. Thank you all. Have a nice day. Thank you very much.
Thank you very much, sir.
Thank you
Dear
so much.
participant, one important announcement. Now we are concluding the technical session 1. The technical session 2 will be started at 2 p.m. sharply. Now time for lunch break. The technical session 2 for the batch 2 oral presentation 1 to 17 will join 2 o'clock. The time duration is at 2 to 4. The 4 to 5:30 technical session 3 will be started for the oral presentation, batch number 2. The poster presentation will be started at 4 o'clock. The poster presentation 1 to 10 will be joined for the technical session 4. Thank you very much, dear participants. Thank you, sir. The separate link will be posted in our WhatsApp group for poster presentation. Dear participants, kindly note that the separate link will be posted in our WhatsApp group for the poster presentation. Thank you, one and all. Thank you, sir.
Thank you so much.
Dear participants, a very good afternoon. Now we are going to start the technical session 2. Be ready. Dear participant, now we are going to start the technical session 2. All the participants are requested be ready to present your research views. Bismillahir Rahmanir Rahim. Distinguished delegates, respected chairpersons, esteemed presenters and dear participants, a very pleasant afternoon. A warm welcome to the 10th International Conference on Recent Advances in Chemical and Environmental Research. It is my privilege to serve as the moderator for this technical session 2. We will now begin oral presentation, batch 1, scheduled from 2:30 p.m. to 4 p.m. Before we start, I kindly request the following presenters to be prepared for their turn. Oral presentation 10, 17, 18, 19, 23, 24, 25, 26, 27, 28, 29, 32, 33, 34, 35, 37, and 47. Each presenter is allotted 6 minutes for presentation, 2 minutes for discussion. I request all participants to adhere strictly to the time limit to ensure a smooth and effective session. All presentations should follow the recommended structure, highlighting the research problem, methodology, key findings, and conclusion. It is my great honor to invite Dr. M. Anwar Sadiq, Associate Professor of Chemistry, to begin the session and introduce the external chairperson. Please, sir.
Bismillah ar-Rahman ar-Rahim. Good afternoon. Assalamu alaikum. Most respected Head of the Department of Chemistry, Dr. Jafar Ahmad sir. Distinguished Chairperson, Dr. Nageswarappa sir, Professor of Chemistry and Director, Center for Device Development, Davangere University, Karnataka. Respected faculty members and dear delegates. I am very much happy to introduce the chairperson of this oral presentation session, Dr. Nageswarappa, Professor of Chemistry and Director, Center for Device Development, Davangere University, Karnataka, act as a chairperson. Sir is currently rendering his service as a professor and chairman in Department of Studies in Chemistry, Davangere University, Karnataka. He has been teaching chemistry for more than 25 years. He has published 211 research articles in well-reputed national and international journals, edited 13 books, authored 15 books, 36 book chapters, 19 patents. He has been involved in functioning various research projects, including the development of low-cost nanoparticles for corrosion resistance funded by the government of Karnataka. Sir has organized more than 63 workshops and conferences at national and international level. He is also the member convener of NAC, peer team, and other important committees. In the above all, he is a very good human being and illustrious alumnus of our department. He is a part and parcel of our department. With these few words of introduction, I hand over the session to Dr. Nageswarappa, Professor and Chairman of Department of Chemistry, Davangere University, Karnataka, to conduct this paper presentation session. Thank you, sir.
Just to introduce ourselves, good afternoon to everyone, all the presenters, the session chairs, head of the department, and all the esteemed members of the Department of Chemistry, Jamal Muhammad College. I welcome all the presenters for this, oral presentation session. Without wasting much time, straight away we'll start the proceedings, presentations by the participants. To begin with, I just go and call upon the presenters along with their numbers and the title. Please be ready and stick on to all the guidelines given by the organizing committee. All your presentations, mode of presentation, and the contents, it should be as per the guidelines given by the organizing team. To start with, the oral presenter number 10, that is evaluation of
Kanmani, Madam Kanmani, are you ready to present? Kannagi.
Sorry, Kannagi.
Evaluation of Rina Santos, leaf extract research green corrosion indicator for my district environment.
By the presenter Kannagi. Kannagi, no? The bold one is the presenter name.
Yes. Ms. Kannagi, you are not present, you are refused.
You are online, share your presentation and start the presentation now. Share the PPT.
The next presenter is Madam Sitra Devi Pallisamy. Are you ready?
The oral presentation number 70. Ms. Chitra Devi Pallisamy is here.
Pencil. Then
Chat లో పాడండి. Chat లో
Oral presentation number 19.
Chat లో పాడండి.
Yes, sir.
Yes, sir. Anthony Lawrence.
Anthony Lawrence, Andrew.
Yes, sir. Shall I present?
Yes, of course, sir. You may proceed.
Number 9.
19, no?
Is the screen is visible, sir?
Yes, sir. Kindly share your presentation, sir.
Is the screen is visible, sir?
No.
Is the screen is visible? PPT
No, no,
is
no.
visible?
No, sir. No, sir.
Now, sir?
Yes. Now it's okay, sir.
Yeah. Make it full screen
Okay.
and start presentation.
Yes, sir. Yes, sir. Yes, sir.
We'll be given 5 minutes
Yeah.
time. Within the 5 minutes time, concluding.
Okay, sir. Okay, sir. So, thank you for giving me this opportunity. I'm Anthony Lawrence, doing postdoctorate in Lakeland University College, Malaysia. So, my research is based on a review of quercetin 3 retinoside metal nanoparticles, in vitro, antioxidant and anti-cancer activity with molecular docking studies. Please. So, introduction about the abstract, we can see that I am going to use the quercetin 3 retinoside, which is a plant-based compound. With that compound, I am going to add with the metal particles, metals such as gold or silver or copper metals. I use a green synthesis method. So from that, I characterize that metal nanoparticles with various characterization such as UV, XRD, TEM, and other characterization. And then going on, I further proceed with the characterization, and then after the activity, the antioxidant and the anti-cancer activity with the molecular docking studies, and future studies is based on the in vivo studies. Okay. So the introduction of the thing is the quercetin 3, which is biological compound, is used. This compound is having a high potential towards the activity based compound. So this compound is having the certain chemical character that has cancer activity and other properties. So with this compound, I'm going to synthesize with the metals, and it gives a new thing that can be further involved in the activities, cancer activities, and other anti-inflammatory activities, other activities. So these are the introduction part. So we are choosing the metals. We are choosing various metals. We can use silver, gold, or iron, or any other metals we can use in order to synthesize this particle. So further, the molecular docking studies is being carried on finally. So synthesis process is that we are using this, it's a natural method, it's a eco-friendly method. So the common synthesis is green synthesis method, which can be of various methods such as microwave assistance or any other method we can adapt this thing. Okay. So the characterizations, I have mentioned a few characterizations such as UV, FTR, XRD, TEM, DLS, all these activities characterization which are easy to find the particle size as well as the nature of the particles. So the compound, the nanoparticles such as gold, silver, and other metals are being used here with a compound. So the in vitro antioxidant activities are examined. We can use that with various methods such as DPPH, ABTS, and FRAP. All this method can be carried on. We can have the manipulation on these things. So the comparative study between this compound, we can compare the metals between the metal, how it reacts with different kinds of metal, how it is being reacted. We can compare that one with the properties also. So the in vitro antioxidant anti-cancer activity, we are going to have a cell line activity. We can use that for a compound for a cell line anti-cancer activity. It can be of any cancer activity which we take, and we can use that one as a precursor. So and then after we can I told no, we can compare these metals with the various metal, which metal is acting better, and which can have a high resolution on that. So, and then also we can use the molecular docking study. We can take the protein and we can adapt on that, and we can use the we can examine that with the quercetin 3 retinoside metal nanoparticles. Further studies that the nanoparticles can be further examined by in vivo studies. Also, we can prolong our studies. So conclusion is that we are synthesizing a natural green synthesis method. We are using the compound and we characterize with many characterizations, and we are finding we are using different kinds of metal, and characterization is being done. And after then we use the application oriented point of view. We are using this anti-cancer, antioxidant, and molecular docking studies in order to know the pharmaceutical applications. Yeah. Thank you for giving me this opportunity. Sir?
Sorry. 0, 0.
Thank you very much, Mr. Anthony Lawrence, for your nice presentation.
Thank you.
Which is used as a standard for anti-cancer studies. Mr.
Sorry,
Anthony
sir?
Lawrence?
Yes, sir. Yes, sir.
Which is used as
Yes, sir.
optimize your
Yeah, we can use this one for anti-cancer activity. Before that, we can have the manipulation that we know the property of the chemical compound, and we can we can see the difference between the metal complex reacted, and after then with the natural compound, we can find the variation between these two things with the cancer cell line.
Okay. What are the scientific challenges you have faced during the optimization of your work? What are the scientific challenges?
The thing is, when we are taking a compound, it is very difficult to have the ratio with that, and with synthesizing the thing. It's a typical thing that the product we get is very low amount. So the synthesis we takes the thing. The synthesis compound is very few that we can get while centrifuging, and we can get.
Okay, you know to do this. Have you learned this molecular docking studies? You know how to do this? That's technical problems.
Okay, thank you very much, Mr. Anthony Lawrence. The next,
Yes, sir.
Thank you very much. All the best for your future.
Thank you, sir. Thank you, sir. Thank you very much, sir. Thank you for this opportunity. Thank you.
Thank you. The next presenter is Madam Kannagi. Madam Kannagi, are you ready to present? Ma'am Kannagi?
Next person. You sure select है? अभी आया नहीं अंदर. अभी आया.
Yeah.
Clip करो किरण.
Sumaj Jain, call next. Okay.
Yes, sir. I'm
Suma J
present.
is present.
Yes, yes, sir. I'm present.
Suma.
Yes, sir. I'm present here. Good
Yeah, you
afternoon,
can.
respected chairperson and all the delegates. I'm Srimati Suma Jeji from Karnataka Science College, Dharwad, Hubli. I just want to share my PPT.
Yeah, please share it and proceed now.
Yes, sir. Thank you.
Given 5 minutes time.
Is it visible, sir? Screen?
Yes, ma'am. Yes. Make it full screen now.
Yes, sir. Thank you,
Go
sir.
to the first slide.
Sorry. Hari.
Go to the first slide, please.
Yes.
Yeah, make it full screen and start.
Yes, sir. Thank you, sir. This is Suma Jeji from Karnataka Science College, Dharwad. I'm a research scholar under Dr. Rajappa SK, Associate Professor, Karnataka Science College, Dharwad from Karnataka. My topic is synthesis of cobalt oxide nanoparticle for ultrasensing electrochemical investigation. My PPT includes introduction, literature survey, experimental part, result discussion, analytical application, conclusion, and references. The precise determination of biologically active molecules garnered a significant attention within the realm of analytical chemistry, as we are using many chemicals in the pharmaceutical industry, pesticides, fertilizers, cosmetic, and etc. So the trace level determination of those chemicals is very much necessary. So we gone through the literature survey where we have seen that cyclic voltammetric techniques have drag the attention towards the low level detection. So where we can use different types of working electrodes. By modifying the working electrodes, we can improve the sensitivity and selectivity of the chemicals. So for that, we have taken cobalt oxide nanoparticle as a nanoparticle as a sensor, and we have used the cobalt nanoparticles as a modifier for the classic carbon electrode. So we have even characterized the prepared material, and for that now we have taken a sulfene pyrazone, a drug used it's a drug used as a uricosuric drug, which reduces the uric acid levels in our body, and we have taken this drug as an analyte. So in the preparation, the chemicals used are sulfene pyrazone, cobalt nitrate. The other chemicals are listed here. And instrumentation, CH instrumentation, pH meter, etc., SEM, XRD, FTR we have used. So coming to the preparation part, cobalt oxide nanoparticles are prepared from cobalt nitrate hexahydrate by using PVA and sucrose as a capping agents. So this is the preparation part. It's a very easy to prepare, and we have got a good yield also. This is the characterization part of the cobalt oxide nanoparticle. So XRD shows shows a good peaks in reference to the card number 421467. By this, we have concluded cobalt nanoparticles are successfully formed. Even FTR concluded that the peaks at 661 and 565 confirmed the formation of CO-O-CO bond. And these are the SEM images where we can see the at different resolution. The formation of cobalt, it shows granular structures. So after preparation of cobalt oxide nanoparticle, we have modified the cobalt nanoparticles, modified the glassy carbon electrode using cobalt oxide nanoparticle just by dispersing the cobalt oxide nanoparticle in a 50% alcohol. After modification, we have checked the surface area of the electrode where we have seen the improvement in the surface area. For bare electrode, the surface area was found to be 0.07, whereas for modified 0.17 centimeters square for a modified electrode. So this must be the criteria for the cobalt oxide nanoparticle to improve its catalytic property. So coming to the sulfene pyrazone electrochemical studies, where in the first image we can see by using the bare electrode, we have seen the peak current only this much, whereas by using the modified electrode, we can see the peak current which shows a high peak current. So we have taken this for the further studies. Even we have checked the pH variations. We have taken up pH solutions from 3 to 10 pH solutions, where we have found that 9.2 pH solution gave a good response. So we have optimized the 9.2 pH solution throughout the study. So this is the how much we have drop costed on the electrode, that is this 2864, where we have seen 4 microliter has given the more peak current, and hence we have optimized 4 microliter drop cost as well as 9.2 pH solution. Even we have conducted the EIS, where we have seen that charge transfer resistance was reduced for the modified electrode, whereas for bare electrode it was high. From this, we can conclude that catalytic properties improved a lot. So this is the ScanRate studies. The sulfine pyrazone, the CV was conducted from the ScanRate 25 millivolt per second to 300 millivolt per second. From this graph, we have found out that the number of electrons involved in the reaction is 2. And as we have seen in the pH studies that there is no involvement in the pH. So here we can see the figure number 3 shows the pH variation, where even after varying the pH, there is no shift in the peak. Hence we have concluded that there is no involvement in the proton in the reaction. So
Suma, you
yes.
can go for conclusion now.
Yes.
Your time.
And this is the electrochemical studies. The square wave voltammetry was used for the calibration curve, where we have detected the chemicals in 5.0 nanomolar 2, and the limit of quantification is 16.7. So these are the interference studies. We have concluded that there is no much interferent from these common chemicals used in. And this is the studies conducted in spiked urine and water samples, where we have got good recovery ranges. The pharmacological sample also is used to check our stability of the electrode, where we have got the good recovery. So the conclusion, cobalt oxide nanoparticle electrode is used for SLF detection at pH 9.2. This mechanism involved 2 electron, and it is a diffusion controlled process. The square wave voltammetry is the first mainly used for this one. Performance, with respect to performance, cobalt oxide nanoparticle classic carbon electrode is highly sensitive, precision, and excellent recovery rates it has given for the biological as well as pharmaceutical samples. And it has good high active surface area, long-term stability, improved sensitivity, superior conductivity, and good repeatability. And so that we can use these electrodes for pharmaceutical quality control, environmental monitoring, and clinical diagnostic. So these are the references. Thank you.
Nice presentation. Thank you, ma'am.
Thank you, sir.
What is the role of polyvinyl alcohol?
Polyvinyl alcohol is used as a capping agent in order to not to aggregate the things which are already formed, nanoparticles. So for that, we have used the polyvinyl alcohol.
Okay. How did you optimize the nanoparticle size?
Size, we have taken 1 milligram of nanoparticle and we have dispersed in a 1 ml of 50% alcohol. After that, this image shows that, okay. Figure number B shows that. So after dispersing the particle, we have drop casted 2 microliter, 8, 6, 4, etc. In that, we have got 4 microliter has given the good response. So that's how we have optimized the thing. Deposition of cobalt nanoparticles.
Okay. What is the particle size? Particle size, what is the particle
Yes,
size?
sir. We have calculated using Skerrer equation. It was 52 nanometers, sir. Unfortunately, I have not added. Sorry for that. 52 nanometer it was, sir.
Go to your SEM now. SEM images you
Yes,
have put.
yes, sir. Okay. These are the same images.
See, by looking into the morphology, what is your
granular morphology, sir? It's a granular morphology, sir.
Okay, Suma. Okay.
Yes, sir. Yes.
Okay, thank you, ma'am.
Final structure it is having, sir, with a granular morphology. Thank you, sir.
Okay, ma'am. Thank you.
Okay.
The next presenter, ma'am Niveta, are you ready to present? Madam Niveta. Madam Kannagi. Ma'am Sitra Devi Palnisamy. OP number 18, Tiwari. Madam Gayatri,
Yes.
OP number 24.
Yes, sir.
Hello.
Okay. Gayatri, ma'am,
Yes,
are
sir.
you ready to present?
Yes, sir.
So OP number 18.
Okay. OP number 18. Diwari.
Yes, sir.
OP
Should
number
I
18.
present first or Gayatri,
Yes, sir.
ma'am
Yes,
will
sir.
present?
Please share your screen.
Mine done. Nodidri?
OP number 18.
Ah.
Diwari.
Sir, is my screen visible?
Yes, sir.
Yes, yes.
Okay, just wait for me to just switch to full screen. Is it visible for the full screen now?
Yeah. So you are moving for this one. 350. Not to avail.
Sir, is it visible full screen?
Yes, sir. Yes, sir.
Okay, so my name is Saurabh Tiwari. I'm a research scholar based out of IIT Roorkee. And this is my presentation. My topic is slightly modified because initially I just started to present only the machine learning part, but later I, changes it to all approaches based on chemical and environmental research based on my material of calcium titanate for the treatment of organic dyes. And sorry for that. So the introduction and the motivation behind this work comes from the industrial water, which is, wasted every time because every time we fabric dye, clothes. And so these are some of the facts which are taken from the internet. And these are some of the facts which help me, how the dye is polluting our, nature in terms of aquatic life, human resources, and all this stuff. So based on this gives us the motivation. So in order to treat this dye, we have different, method or techniques. And you most have known about the photocatalysis, the piezocatalysis, and the later one known as the tribocatalysis. So my works revolve around these dyes and the preparation or the treatment of these dyes with the help of these different methods. And the schematic shows what are the different sources which I have used. And the main quantities of my interest includes how these dye treat, and after treatment, what can we do with the treated water, all these stuff. And based on this, we'll try to determine what are the different methods of treatment and how can we use two different methods. So everything starts with the characterization because we wanted to know whether our material is, developed or not, whether it is under the standards of not. So for that, we use 4 different characterization techniques, including the known XRD and SEM. Later, we go for the DRS-based technique for determining the band gap. And finally, we'll go for the XPS for determining all the chemical composition properties based on this band structure and all this. We can determine with the help of these techniques. Now, there are different mechanisms of dye degrading. The 3-1, which is the photocatalysis, the piezocatalysis, and the tribocatalysis. All the mechanism are shown here. Now, in case of photocatalysis, light is generating, absorption of light from oxidation to valence band to conduction band. Then these generate charge carrier. Based on this, a redox reaction is accumulated, and based on this, we'll degrade the dye. Same mechanism will carry forward for piezo and tribocatalysis, which I haven't shown here. Now, these are some of the results. Based on these results, you can determine the 3 different processes, how the dye is degrading with the help of UV visible spectrometry. And then degraded dye can be a function of, the time, light source, effect of particle size, initial particle exploration, and all these. And in order to determine the degradation efficiency, we compare the photocatalytic, piezocatalysis, and the tribocatalytic performance of calcium titanate. And based on this, we determine the synergical study. But what happened next? After treating the dye, what we are going to do is a major concern of my research here at IIT Roorkee. So first we make that treated water and put that treated water into 3, samples of seeds. The seeds are mentioned here. It includes the seed of Virginia radiata, which is known as moong dal. Then we have Tritium acidium, common wheat, and then we have Caesar atrium, that is the pig seed. And we try to determine the germination index based on how the germination is going to perform and how they are going to operate. Based on this, we also determine the techniques. Later, we go for the antibacterial analysis. What will happen if we put our treated water in sort of, as an antibacterial agent, and these are the famous known antibacterial process using flow flotation, which includes all the steps. And I mentioned the inoculation of strain, then autoclaving, growth flotation, nutrient preparation, preparation of nutrient. We use E. coli and Streptococcus aureus as our 2 antibacterial agents for determining those techniques. Later, we shift for the soil testing procedure, we treat water, then we put that treated water in the soil. The tests were performed at the campus soil, and we determined the different constituent of soil, which includes the soil pH, the conductivity, the NPK constituent, the zinc, the microconstituents, the minor constituents. All these constituent has been determined in order to determine whether the treated water can be used for agriculture purpose or not. Later we go for the biodegradation analysis. We treat, plastic sort of thing, put our treated water and try to determine whether our
Sir,
treated water
Tiwari
can
sir,
able to be.
sorry
Yes,
for
sir.
the interruption. Move to conclusion section, sir, please.
Okay. So this is my antioxidant analysis. We perform the antioxidant analysis using the DPPH solution. And later we go for the machine learning based approach to determine what could be the possible degradation efficiency. And these are my conclusion, in which we use the degraded dye, different catalytic performance. Based on this, we determine the materials verified by that characterization. We go for environmental assessment using different soil-based techniques, and we go for the water quality. And thank you with that.
Thank you, sir. Very nice presentation.
Thank you, sir.
Sir, what are the uniqueness of your studies? What are the uniqueness? Already,
Okay, so
lot of works reported in rhodamin B degradation. In what way your work is superior, or what are the uniqueness?
okay. So I know a lot of work has been reported in rhodamin B, and people have done a lot of work in the case of photocatalysis. But the new things in my case, it's the newer techniques like tribocatalysis and the pyrocatalysis. That's the first thing. And after treatment of dye, nobody puts that treated water in the form of soil. We just treat the water, but we never put that water into soil. And if I put that water into soil, I can use the dye degraded water for agriculture purpose. That has been never been done before. So in order to determine whether that water is fit for agriculture, we need to determine the before water test results and the normal water result with the treated water, like the soil concentration, NPK, whether the water can be used for the determination of, micronutrients of soil, how it affects the pH of soil. That has been the major landmark and major milestone of my project.
The particles you have synthesized, no? From the XRD, what is your, particle size you obtained?
Sir, at XRD gave us the crystal structure. Particle size we have obtained with the help of SEM images using that software, and the particle size gives around 40 to 60 micron. This is a microparticle. We have synthesized using the solid state technique using precursors.
Okay. You go to the your XRD now. XRD. Move the slide.
This one.
Yeah. How much you are reporting that?
Sorry,
You
sir.
said 40, you said 40.
Yeah, it can be very, sir, because like for showing for the presentation purpose, I am showing the smallest particle can be possible. But every
Yeah,
time, you
of
know,
course,
we
of
go
course,
for,
of course.
yes,
All
sir.
that
That's why
calculation.
if you
It's
if you
okay,
go
Tiwari.
based on this length bar, it was around 2 to 3 micron, but overall the average particle size is around 40.
Fine. Okay. Okay.
Thank you very much, sir.
Thank you, sir. Thank you for your time, sir.
The next presenter is OP number 24, Madam Gayatri.
Yes, sir.
Madam Gayatri. Okay, ma'am.
Okay.
Please share your screen.
Yes, sir. Sorry, sir.
Yes, ma'am.
Yeah, make it full screen.
Yes, sir. Good
Okay,
afternoon.
start.
Yeah. My name is M. Gayatri. I am a research scholar from the Department of Biochemistry, Vista, My research work focused on the phytochemical analysis and antioxidant potential of Rosa damascena flower extract. Aim of my study is to identify the bioactive compounds present in different solvent extracts and evaluate their antioxidant activity using various in vitro assays. Now I would like to begin my presentation. Introduction part. Rosa damascena rose is valued for its fragrance, traditionally used for its anti-productive properties. Oxidative stress contribute to neurodegenerative disorder like anxiety. To evaluate solvent-dependent variation in the phytochemical and antioxidant properties of Rosa damascena. Objective of this study: investigate the phytochemical composition of Rosa damascena extract using different solvents like water, ethyl acetate, methanol, and chloroform. Evaluate their antioxidant activity using in vitro assays. Explore the therapeutic potential against oxidative stress related disease. Then we go for methods and materials. First, we collect the normal rose petals and dried, then powdered. We use powdered rose petals. Procedure of this study: first, phytochemical analysis. The plant was extracted using 4 different solvents. Using this extract, the presence or absence of bioactive compounds were checked. These compounds include tannins, glycosides, steroids, etc. Antioxidant assay. Antioxidant tests were done using different in vitro assays. Extracts were tested in the concentration range 50 to 250 mg per ml. Extract is needed to neutralize 50% of free radicals. Lower IC50 value means stronger antioxidant activity. Then we go for results. First one is phytochemical test. Tannins present in water, chloroform, water, methanol, and ethyl acetate extract. Vital oil present only in chloroform extract. Steroids present only in ethyl acetate extract. Glycosides, terpenoids, cardiac glycosides, saponins not found in any extract. So the different solvent extract different components based on polarity. Then antioxidant assays. First one, superoxide anion scavenging assay. This is moderate activity, needs a higher concentration to show effect compared to others. The chloroform extract shows the lowest IC50 value. Then hydroxyl radical scavenging assay. Good ability to neutralize the harmful hydroxyl radicals. Ethyl acetate extract is effective at this concentration. Then APTS scavenging assay. The APTS scavenging assay weak activity compared to other extracts, needed a high amount to show antioxidant effect. Then nitric oxide radical scavenging assay. This is moderate antioxidant power. Methanol extract shows some ability to neutralize nitric oxide radicals. Then DPPH assay. DPPH assay is the strongest antioxidant result among all tests. Very low IC50 value means high free radical scavenging capacity. Then hydrogen peroxide scavenging assay.
Madam?
Yes, sir.
Move to conclusion.
Okay, sir. The conclusion part, the discussion part of this study related that Rosa damascena flower extract contain important phytochemicals such as tannins and steroids. Ethyl acetate and chloroform extracts show better extraction of active compounds. This presence of this study bioactive compounds contribute to the antioxidant potential of the plant. Overall, Rosa damascena shows good medicinal and therapeutic potential due to its natural antioxidant properties. Conclusion of this study: Rosa damascena extracts contain bioactive compounds with strong antioxidant activity. Ethyl acetate and chloroform extract exhibit the most promising results. These findings suggest the potential use in neuroprotection and management of oxidative stress. Thank you. Thank you, sir.
Thank you, ma'am. Nice presentation. The next presenter is OP number 25, Madam Swadhisree. Swadhisree, Absent. OP number 26.
Yes, sir. Yes, sir. Present, sir.
Okay, ma'am. Please share your screen.
Is my screen visible, sir?
Yes, ma'am. Yes.
Good afternoon to one and all present here. I'm Swajishri from the Department of Biochemistry. I'm going to present on the research paper, Comprehensive Analysis of Phytochemicals and Antioxidant Properties of Quinoa Seed Extract. The introduction goes with quinoa, which is Simai Thinai in Tamil. It is a nutrient-rich pseudo-cereal from the Andean region present in US. It is valued for its high nutritional content and therapeutic potential in managing many metabolic disorders like cardiovascular disease, etc. And it contains high quality protein and 9 essential amino acid. It also contains diverse phytochemicals contributing to strong antioxidant activity. The main objective of the study is to perform the qualitative and quantitative phytochemical screening and to evaluate the antioxidant activity using 7 different assays. For performing the 7 different assays, we have used various different solvents such as ethyl acetate, ethanol, methanol, and water. And the last objective of my study is to identify the potential of quinoa as a natural source of bioactive and antioxidant compounds. The material and methods includes the quinoa seeds has been brought from a local source of market and it has been finely powdered for the solvent extraction. Then the procedures followed for the phytochemical analysis and antioxidant assay were the standard procedure. Let's move on to the results. The phytochemical screening of quinoa seed extract, we have done both qualitative and quantitative phytochemical screening. In the qualitative screening, we can see that alkaloids, saponins, and steroids were present in ethanol, methanol, and aqueous extract, whereas tannins, glycosides, cardiac glycosides, and volatile oils were completely absent in all the 4 extracts, and terpenoids were present only in aqueous extract. In the quantitative screening, we can see that ethanol, in the ethanol extract, alkaloids were present in 3.2 mg per gram, and in methanol extract, it was present in 3 milligrams, and in aqueous extract, steroids were present in a very little amount of 1 milligram, and tannins, saponins, terpenoids, and cardiac glycosides were completely absent in all the 4 extracts. Then we will move on to the antioxidant assays. In the superoxide anion radical scavenging assay, we can see that the ethyl acetate extract exhibited the lowest IC50 value. IC50 value is nothing but the extract which is needed to neutralize the 50% of free radicals. Low IC50 value indicates the stronger antioxidant activity. Next, we will move on to the next assay, hydroxyl radical scavenging assay. Here, the concentration range which has been taken for all the assays is from 50 to 250 μg per ml, and the x-axis is taken in concentration, and in y-axis the inhibition percentage has been taken. In hydroxyl radical scavenging assay, the ethyl acetate showed the lowest IC50 value of about 113.56 μg per ml. Next, in hydrogen peroxide scavenging assay, aqueous extract showed the lowest IC50 value of about 107.66 μg per ml. In the nitric oxide radical scavenging assay, the ethyl acetate. Yeah,
Sorry
yes,
for
sir.
the interruption.
Yes, sir.
Move to conclusion, please.
Okay. Okay, sir. Sure, sir. Here we can see that PBPH assay had the very strongest antioxidant strength among all the assays. So we can see from the discussion that from the results, aqueous and ethyl acetate extract exhibited the more strong antioxidant activity, and the 5 high phytochemical content were present in alkaloids, glycosides, and volatile oils. And the solvent polarity was influenced with the extraction of bioactive compounds. And from this, we can conclude that that quinoa contains diverse phytochemicals with a strong antioxidant potential, and the aqueous and ethyl acetate extract showed the most effective radical scavenging activity. And from here, we can conclude that quinoa is a natural source of antioxidant, and it can it is utilized for nutraceutical and therapeutic formulation to combat the oxidative stress. Thank you, sir.
Okay, thank you, ma'am. Nice presentation.
Thank you, sir.
Madam, you have selected 4 solvents: ethyl acetate, ethanol, methanol, and aqueous.
Yes, sir.
Correct?
Yes, sir.
What are the reasons?
Sir, actually, the study is undergoing, sir. Now we are going to check. From this study, we have concluded that ethyl acetate has been the most strongest solvent with my extract. So I'm going to choose with for the further study. I'm going to go with the ethyl acetate extract, sir.
Okay, all the best, ma'am.
Okay, sir. Thank you so much, sir.
The next presenter is OP number 26, Jyoti Sharma.
Yes, yes, sir. Am I audible?
Okay, ma'am. Please share your screen.
Sir, is my screen visible?
No, ma'am, no.
So still not visible?
No, ma'am, not visible. Madam? Okay. OP number 27, Dilip Arogyaraj. Are you ready to present? OP number 27. Absent. OP number 28, Surya Farooq. Are you ready to present? Okay. OP number 17, Madam Sitra Devi.
No, sir. Yes, sir. Yes, sir.
Please share your screen.
Mobile. Is my screen visible, sir?
Yes, ma'am. Yes. Surya Farooq.
சார் இது வந்து ஆக்சுவலா ஸ்கிரீன் அதுல தானே தெரியும்
மேடம்
கரெக்ட்
இதுல பார்க்க முடியாது ஸ்கிரீன்
So this is OP number 26. Is my screen visible?
OP number 28. Are you ready to present?
Hello, sir. Yes, sir. It's me, Surya Farooq. I'm ready. Should I present?
Yes, ma'am.
Okay, sir.
Surya
Okay,
Farooq.
sir. So is the screen visible?
Yes. Yes, ma'am. Yes.
Good afternoon, everyone. This research has been done in a northern district of Jammu and Kashmir on the municipal solid waste generation management and the challenges which are facing. So as everyone knows that solid waste generation these days is a huge concern everywhere in the world because of the increasing population, boost economy and urbanization and all. So this study, we checked the composition and the generation and this the management part. So this is the study area. This is the northernmost district of Jammu and Kashmir. So this is a very beautiful district, but unfortunately the waste management system is very poor. So presently, what we find that there are a lot of challenges, where starting from the collection, with transportation system, with the this treatment and disposal sites, and these wastes are being dumped in the river banks, these in open fields. So you can see in these pictures that the waste is, this municipal waste is transported in these open vehicles, and then it's been spread in open fields, in the river banks, which separates fall, smell, and diseases. So as you can see in these canals and the banks of these canals, this waste is being dumped. So which becomes the cause for the various diseases like diarrhea, dysentery, typhoid, and all. So we did this study to check how much waste is being generated in this district, especially in the town area. We selected 15 wards, and we see what we can do for this waste. So what we find that this and we also did a questionnaire there. So what we did, we distributed these poly bags which has capacity of 10 kgs. We distributed these bags when at 8 o'clock. Then after 24 hours next day at the same time, we collected them back, and then we weighed them, and then we segregated the waste which has been generated from the households. And what in results we found that food waste was the highest which was being generated. That like as you can see in the table, that 0.071 we see per person was generating from each household. So from this study we find that there is a solution that we could use this in this particular area. We could use this waste as this organic waste is high generated in high manner, so we can use this waste in composting method. So we are planning to do another part in this, and we also circulated a questionnaire which comprised of 8-9 questions. So we asked people how many they are dealing with the waste and all that. So by this study, we find that food waste is the highest. As you can see in my slide, that we can convert that into manures, which can boost our economy as well, and will be helpful for this well-beingness. And from responses we received that plastic and polythene are generated every day, very much from households and from marketplaces as well. And the main reason is due to lack of funding, shortage of waste bins in this district, and due to inappropriate working. So this district is facing a lot of this difficulties dealing with this waste. That was all. Thank you so much.
Nice presentation.
Thank you, sir.
Madam?
Yes, sir.
Surya Farooq?
Yes,
Ma'am?
sir.
Okay. The next presenter is OP number 29, Rihana Farooq. Are you ready to present?
Otherwise,
Madam Jyoti Sharma?
yes, sir.
OP number 26. Are you ready to
Yes, sir.
present?
Yes, sir.
Please share your screen.
Is it visible to you?
No, ma'am. Yes, yes.
Should I continue?
Okay, ma'am. Okay.
Okay. So, a very good afternoon to all of you. My name is Jyoti Sharma and I am working as assistant professor in Department of Computer Science, Degree College, Udhampur, Jammu and Kashmir. The topic of my today's presentation is ethics, fairness, and policy implications of AI in environmental decision making. A socio-technical governance. Environmental science and policy. They were shaping decisions pertaining to climate modeling, remote sensing, pollution monitoring, and energy optimization and much. Objective power of AI helps in optimizing this training data. Hidden bias algorithms reflect existing societal crises leading to unequal treatment in different communities. For the successful implementation of environmental governance, local communities, rural populations, and economically disadvantaged groups need to be included. AI models used so far are only as good as the training data, which in environment science is often incomplete and biased. The complex black box nature of most current AI models further creates critical transparency problems for environmental governance. These opaque systems may make high-stake decisions that include drawing pollution boundaries, allocating emergency resources, or setting priorities which public or regulators cannot implement. The life cycle of environmental AI system involves data provided from model developers, software vendors, government agencies, and end users, all of which are equally accountable for implementation procedure to be successful. AI models can optimize for efficiency without considering equity. Participation should be inclusive to ensure the involvement of marginalized communities when it comes to influencing the way AI tools shape environmental policies. For fair and just environmental governance, it is important to acknowledge local ecological knowledge, local practices, and community-based observations. AI system used to predict wildfire risk usually rely on historic fire data and socio-economic indicators. For example, in case of agriculture subsidies, AI model trained on monocultural farming failed to recognize polycultural ones. AI-based climate models may produce unreliable predictions in data per regions. Here is a socio-technical governance framework which is proposed. Document data sets, modeling choices, assumptions, uncertainties must be considered. Accountability mandates, clear responsible pathways, regular audits, and legal redress mechanisms should be followed. Environment Ministry should issue enforceable guidelines. These are the steps that need to be taken at national level. Environmental ministries should issue enforceable guidelines for the procurement and deployment of trustworthy environmental AI. Investment should be made to train policymakers and regulators in AI ethics and critical data literacy. Now comes the international level. The UN Framework Convention on Climate Change, Convention on Biological Diversity should establish working groups to develop protocols for ethical use of AI. Infrastructure and data sharing should be developed through organizations like ISO for transparency, accountability, and justice in environmental AI. These are the future directions. The experimental work evaluating real world outcomes of AI on front is needed. There is a requirement of integration of AI ethics with environmental justice frameworks to understand long-term ecology impacts of AI systems. Participatory design and community-driven governance for environment must be developed. Global coordination and standard policy frameworks need to be improved. Lastly, it can be said that the deployment of AI in environmental domains must not aim for technological novelty, but also for fairness, justice, and ecological resilience. Thank you, sir.
Okay, thank you, ma'am. Nice presentation.
Thank you, sir.
Ma'am belongs to which department?
Computer science.
Okay. All the best, ma'am. All the best. Nice presentation.
Thank you, sir.
The next presenter is Mr. Akhtar Kubai. Mr. Akhtar Kubai, are you ready to present?
Sir, can I
Yes, sir.
present?
Yes, sir. I am ready to present.
Yes, sir. Please share your screen.
Yes.
Yes, sir.
Visible?
Yes, sir. Yes, sir.
I am Hubai, Assistant Professor, PG and Research Department of Chemistry, Islamia College, Waniambadi. I am here to present my research on computational symmetry analysis and property prediction of alkali hexafluorocomplexes across multivalent central atom. This study focuses on understanding how structure influence electrolyte behavior and how we can use computation as a screening tool to identify high-performance electrolyte material efficiency. Electrolytes are core component of lithium-ion batteries responsible for ion mobility, charge transfer, and long-term cycling stability. Conventionally, new electrolyte salt are discovered experimentally through synthesis approach, which are expensive and time-consuming as well as unsafe due to moisture sensitivity and decomposition. So instead of beginning blindly in lab, our work proposed a computational pathway to predict stability and reactivity before synthesis. The innovative component of this study is application of molecular descriptor derived from highest occupied molecular orbital and lowest unoccupied molecular orbital values, particularly the focus on electrophilicity index, which we identify as a powerful indicator of electrolyte suitability. Traditionally, lithium hexafluorophosphate is one of the most widely used commercial electrolytes. Known drawbacks such as instability at high temperature and evolution of hydrogen fluoride gas. This motivated us to search computationally for better alternatives. In this study, we examined 15 lithium-based hexafluorocomplexes, including scandium, gallium, aluminium, cobalt, zinc, manganese, iron, chromium, nickel, vanadium, bismuth, antimony, phosphorus, titanium, and arsenic-centered system. Using HUMO-LUMO energies obtained from computational results, we calculated HUMO-LUMO energy gap, electronegativity, chemical hardness, softness, and electrophilicity index. These parameters help us to understand how molecules behave electrically. For example, a smaller HUMO-LUMO gap means easier electron excitation and higher reactivity. Then hardness tells us resistance to charge deformation. Higher hardness means less reactive. Low hardness means softer and more accommodating. Electrophilicity index, which combines electronegativity and hardness, indicates electron accepting ability. A high electrophilicity index means molecule can stabilize incoming charge very efficiently, a desirable property for electrolyte. So in this table shows for the 15 electrolyte, we carried out theoretical as well as experimental calculation for there are two different methods, which is VASP, Veena Ab Initio simulation package, and another one is DFT, hybrid functional calculation, which is B3LYP double zeta calculation. So in particular, we selected electrophilicity index for the ranking the out of 15 electrolytes. So now let us look into the results, when we ranked all the compounds based on electrophilicity, a striking trend appears. For example, lithium hexafluorose candidate shows the highest electrophilicity index value, which is 115.115.68, followed by 97.68 and 94.09. These values are extraordinary high compared to lower end of the list. On the opposite side, lithium hexafluorophosphate exhibited only about 6.65 and lithium hexafluoroarsenate around 5.07, nearly 15 to 20 times lower than the top performing compounds. So this means that the commonly used lithium hexafluorophosphate, although commercially popular, is not the strongest electron accepting candidate for compared to various unexplored alternatives. This highlights a strong possibility for next generation electrolyte development if we evaluate and synthesize candidate salt with significant better properties like lithium hexafluoroscandate. So in this slide, there is a correlation between HOMO-LUMO and...
Sir, sorry for the interruption.
Yes, sir.
Please move to conclusion section.
Yes, sir. Yes, sir. Is going to be in 1 minute. Just. So high electrophilicity compounds tend to a smaller energy gap. A smaller means a smaller molecule can participate in electron transfer more readily, support ionic conduction. So similarly, we correlate with another observation, which is hardness and softness with electrophilicity. Result, from this interpretation, we established a screening rule for electrolyte design. Best electrolyte candidates, high electrophilicity, low hardness, small HOMO-LUMO energy gap, and strong electron accepting nature. These rules eliminate random testing and direct synthesis only towards a strong performers. So to carry out this work, we utilize the methods, which is VSP, DFT hybrid, functional. So this significance of this work is instead of experimentally trialing dozens of candidate salts, computational screening allow us to shortlist compound like lithium hexafluorose candidate, while compounds like lithium hexafluorophosphate and lithium hexafluoroarsenate remain low priority. These reduce cost, material loss, and time consuming and guide battery researchers towards meaningful targets. So I conclude, we have successfully shown that molecular descriptor can readily rank electrolyte material and that there exist several lithium complexes computationally superior to current used as lithium hexafluorophosphate. The highest prospect were found for lithium hexafluorose candidate. Our approach saved time, cost, and experimental risk, opening pathways for the rapid development of high performance battery electrolyte. Thank you, sir.
Nice presentation. Thank you, sir.
Thank you, sir.
What about the cost of lithium scandium hexafluoride? What about the cost?
So we experimentally synthesize by using available reagents, which is lithium cobalt oxide. So we prepare one of the electrolyte, which is lithium hexafluorocobaltate. Not we prepared a scandium based electrolyte. So we prepared cobalt based complex. So we prepare from the available reagents. For example, lithium cobalt oxide and with the other reagents.
What about the stability?
Yes, sir. We study the stability as well as experimental as well as theoretical works.
Okay, sir. Thank you very much. Nice work.
Thank you, sir.
The next presenter is OP number 29, Rihana Farooq. Rihana Farooq, are you ready to present?
Yes, sir. Yes, sir. Ready.
Okay, please share your screen. Madam,
Yes, sir.
please share your screen.
Yes, sir. I am sharing it. I'm not able to share it. Sir, is my screen visible?
No, ma'am.
Kannan sir, kindly put the co-host for Rihana. Kannan sir. Yes.
Yes, ma'am. Please present now.
Yes, sir. Share screen.
Once again, try to share the screen.
Sir, I'm trying.
Okay.
Sir, I will connect from other scholars system. Can you give me 5 minutes? I will connect them.
Okay, ma'am.
Till then, you can ask other presenter to share.
Okay.
Thank you.
Madam Durga, are you ready to present? Madam Durga,
Yes, sir.
please share your screen.
Sir, whether my screen is visible?
No, ma'am. No, sir.
Sir, now?
Yeah. Okay, ma'am.
Okay, sir. Good afternoon to one and all. I'm Durga Maniganda, Assistant Professor, Department of Chemistry in ADM College. Today, I am going to discuss about synthesis and characterization of biodegradable bioplastic film from banana peel. Already, we know that biodegradable bioplastic. This is the abstract. Just I want to say that what is bioplastic? What is mean by bioplastic film? Bioplastic is nothing but it is a biopolymer and can easily degradable. A bioplastic film is we can use it as a biodegradable products. In this, I'm using what are the characterization I have used is FTIR and DSC and solubility test and biodegradable test. My main aim is banana peel has a rich source in cellulose, starch, and pectin, which are used for production of the bioplastic film. In this, I'm added a cinnamon powder. It acts as preservative, and I add 3 ml of honey and 3 ml of glycerin. This glycerin and honey is used as a copolymer. And then in this, the starch already we have discussed in our topic. Starch I have used is potato starch to blend together it that I was shown in my
procedure picture. Okay, a related pictures are given in the about starch. In this, the FTIR result is we are seeing this. Glycerol had alcohol. So the peak of alcohol we have insert in this graph. Is it is visible? The FTIR graphical image.
Yes, it is visible, ma'am.
Then DSC. DSC is nothing but with a differential scanning calorimeter. It is used to identify for thermal properties. This image is graphical image of DSC. Solubility test. Next, solubility test is nothing but the bioplastic. The made bioplastic is soluble in water or insoluble. My bioplastic was soluble in ammonia and sulfuric acid because it has high effective acidic nature, but it was not soluble in water and acetic acid because we know that acetic acid is a weak base. Then biodegradable test. Biodegradable test is nothing but normally normal plastic takes 2 to 100 years to degrade, but this bioplastic can degrade within 12 days. This is the test. And the application is food packaging for wrapping a food, vegetables, snacks, and biodegradable alternative plastic wraps. And we can also use it for agriculture mulch films. And single using package without, while you're going to glossaries, we can use this bioplastic film. A pharmaceutical packaging, seed post and seed wraps, eco-friendly stationery. And these are the related image. We know that where the bioplastic was existed, we don't know that Mesoamerican peoples was used the bioplastic film, natural lactose and the rubber as a comb, plastic water bottle for carrying a enable things from there where we want to go. We don't know that where the bioplastic were existed. Mesoamerican people only one they have existed the bioplastic film. And then in 1920, Henry Ford experimented a car for a kids for playing a car material with using a soya bean paste. Soya bean paste is nothing but blended the soya paste, and the residue is taken with potato starch and glycerol and honey and cinnamon powder for preservative. The process I have told about the process. Instead of potato starch, I have taken Henry Ford is taken soya bean. And till now, in America, the banana peel package is used for tea making, tea bag making. We are day-to-day life, we are using plastic bags like green tea. Instead of that, nowadays natural banana peel is they have banana peel plastic they have used. Thank you, sir.
Okay, ma'am. Nice presentation, nice work. What about the cost of your bioplastic?
Sir, it is not cost efficiency, sir. We will take just you want to pay for characterization only. We have to take a cost, but in the glycerol, honey, these are natural polymer. Like we have already, it was in our house only, so we can able to take it from the house itself. We need to buy from outside.
Okay. Thank you, ma'am.
Thank you.
The next presenter is OP9, OP17. Sitra Devi, Madam Sitra Devi, are you ready to present?
Yes, sir.
Please share your screen. OP number 17.
Sir, my screen is visible, sir.
No, ma'am.
Sir, can I present? It's Rehana.
Penin sir, kindly provide the co-host to Chitra Devi. Yes. Ma'am, you can proceed. Chitra Devi ma'am. Chitra Devi ma'am.
Sir, 2 minutes, sir.
Ma'am, Chitra Devi ma'am, please wait
Sir.
for some more time.
So once minute.
Chitra Devi ma'am,
Sir,
please
yes,
wait
sir.
for some more time. Madam Righana, are you ready to present? Madam Righana,
Yes, sir. Yes, sir.
please share your screen.
Sir, is my screen visible?
Yes, ma'am. Yes, ma'am.
Sir, it's me, Rehana. I'm doing PhD under Dr. Jaswinder Singh in Lovely Professional University, and I'm presenting on the enhanced photocatalytic activity and stability of green sunshine manganese lead sulfate nanoparticles for the photocatalytic degradation. So my presentation contents are introduction, literature review, research methodology, results, and conclusion. Wastewater is the water which is hazards, having contaminants, and this water is generally resulted from the human activities, from the pollution, from pesticides, from these fertilizers, chemicals. So wastewater, it's if not treated properly, it can harm the environment, social, and also the health aspects. So this undertreated wastewater often it contains harmful chemicals such as heavy metals and pathogens. These are the sources of water pollution which have been taken from these references, and this is the data which has been wastewater production across different regions of the world. And this is the endocrine disrupting chemicals, those chemicals which have potential to exert negative effects on the endocrine systems of humans as well as wildlife. So the sources might be the hospitals, industries, pesticides, or these PCPs. So they may have effects both on humans and wildlife. Like humans can cause asthma, cancers, these diabetes, reproductive abnormalities, and in wildlife they can have cardiovascular diseases and metabolic diseases. So some examples are like bisphenol, oxybenzole, and dichloromethane. So this is the review of literature what we have done, and this is the synthesis of CDS and nickel doped cadmium sulfate which we have done by the extraction by preparing the banana peel extract. Then these are the results which we have got for the XRD analysis for, preparing CDS and nickel CDS nanoparticles. And this is the FDR spectra we got. You can see the peaks observed for the moisture, for water molecules, for sulfate groups, and for CDS stretching. And this is these are the same images for CDS and for nickel doped this EDS spectra of the synthesized CDS and nickel CDS and electrical mappings. And these are the TGA analysis of CDS and nickel CDS for 0.4 nanoparticles. And these images also show the UV visible absorption spectra of CRP during visible light irradiation in the presence of nickel CDS. And in conclusion, find the SAM analysis showed that CDS nanoparticles tend to aggregate, forming uneven clusters due to the high surface energy, which reduces active surface area. In contrast, nickel doped CDS exhibits a more uniform and well-dispersed morphology with smaller particles and fewer aggregates. This improved distribution provides more active sites, enhanced surface area, and supports better charge separation, ultimately contributing to higher photocatalytic performance. And these are the references. And thank you so much.
Okay, thank you, ma'am. What about the nature of cadmium sulfide based nanoparticle? What about the nature?
Yes.
Okay. What about the basic nature of cadmium sulfide based nanoparticles? Okay, thank you, ma'am. Ma'am, Sitra Dev, ma'am, are you ready to present?
Sir, some other issues, sir, handling. Give me for 2 minutes, sir.
Okay, okay, ma'am. Sahul Hamid, Mr. Sahul Hamid, are you ready to present? Mr. Sahul Hamid, okay, absent. Madam Afra, OP number 33. Madam Afra, absent. OP number 34.
Sir, I'm there.
Madam Afra.
Yes, sir, I'm there.
Yes, sir, please share your screen. Okay. Madam Afra.
Sir, I'm unable to share. Can you make me co-host?
OP number 34, Navya Anthony. Absent. OP number 37, Shankar. OP number 47, Supriya. OP number 10, Kannagi. Madam Kannagi.
Yes, sir. I'm Supriya.
Okay, okay. Supriya, Madam Supriya, please share your screen. OP number 47.
Okay, sir.
Okay, ma'am.
Sir, I am
Please.
Supriya.
Okay, okay, ma'am.
Research scholar from Karnataka Science College, Dharwad. Today, I am going to present about my work, copper telluride nanoparticles for electrochemical sensor to detect the diclofenac sodium. These are the some contents of my presentation. Then, in today's environment, pharmaceutical pollution is growing very fastly due to the non-steroidal and anti-inflammatory drugs like diclofenac sodium. Diclofenac sodium is widely used for the pain, inflammation, and it is poorly biodegradable. That's why it is increasing pollution in the water. This is the structure of diclofenac sodium. To detect the diclofenac sodium, there are many conventional methods are there like HPLC, GCMS, UV visible, and some others are there. In that, electrochemical sensors are also used to detect the diclofenac sodium. For detecting the this diclofenac sodium, we have to develop a material. For that, we choose the copper telluride nanoparticles for the electrochemical sensing of diclofenac sodium, because it is an excellent conductive material and has high electrocatalytic activity. So we synthesized copper telluride nanoparticles by hydrothermal method using copper chloride and tellurium metal powder and reducing agent hydrazine hydrate. So we got copper telluride nanoparticles. To confirm the phase and its crystal, we have done some characterization. In that, we done XRD to confirm the phase, and by Rittville refinement, we confirmed that it is a Cu2Te phase with space group P3M1, and from the bond length and bond angle, we confirmed that it is a hexagonal structure with trigonal symmetry. Then from Vesta, we got this copper telluride structure. It is a layered material which is having first layer, second layer. In that, between first layer and second layer, there is an interstitial copper atom is present, which is having oxidation state 0, which will help in the electrochemical conductivity. So these are the some polyhedral structure of the copper telluride nanoparticles. Then from XPS, we got the confirmation of copper is in the +1 state and tellurium is in the -2 state. Then we also done TM, transmission electron microscopy, and it is well matching
Madam, move to conclusion section. Madam, move to conclusion. Madam Supriya. Okay, Madam Chitra Devi.
Chitra Devi, kindly unmute your audio. Are you ready to present your views? Ma'am Chitra Devi.
Madam Afra. Madam Afra.
Yes, sir, I'm ready. Am I audible?
Please present. OP number 33.
Sir, am I audible?
Yes, ma'am. Yes.
Yes. So is my screen sharing, sir? Is my screen shared, sir?
No, ma'am.
1 second.
Yes, ma'am.
Yeah.
Kindly move your first slide.
Yes, sir. So good afternoon, one and all. My name is Dr. Afra Kausar Nadaf. I'm an assistant professor. in the
I'm sorry
Department
for
of
the
Chemistry.
interruption. Kindly.
Yes, sir.
Yes, okay.
Yeah. Sir, is it visible?
Yes.
Yes, ma'am.
Yes. So it is Dr. Afra Kausar Nadaf, assistant professor, Department of Chemistry from Hubli, Karnataka. Today I am presenting about the in vitro and in silico evaluation of anti-hyperglycemic, antioxidant and anti-inflammatory activities of some imidazole acrylonitrile derivatives. So the challenge is about the diabetes. Diabetes mellitus, a prevalent complex metabolic disorder, which is having serious concerns. To tackle these diabetes, basically with me, I have two solutions. Two things can be done. One thing is by promoting glucose uptake, that is by activating our PPAR gamma protein. Second thing what we can do to tackle this is by reduction of breakdown of starch into glucose, that is carbohydrate metabolism. This can be done by inhibiting alpha amylase enzyme. So to do these two tasks, we need some pharmacophores. These pharmacophores I found in the terms of imidazoles, which is an heterocyclic compound, which is biologically available and is present in many of the drugs. So what did we do is, we took up this imidazole and we synthesized some of the molecules. Prior to our synthesis, we have done the computational studies on them using the molecular docking studies. Then when we were satisfied with the activity, then we have gone for the in vitro synthesis and the in vitro activities. So what we have done is, we have designed these molecules, an above molecule, that is 14 molecules, and out of the 14 molecules, the 5 below molecules have shown good binding affinities. So we took out these 5 moieties and we moved ahead with our research work. So initially we prepared a protein using the Ramachandra plots. Then we checked for the ligand efficiency approach with this standard as well as this 5 pharmacophores what we have taken. All of them have shown good binding affinity comparable to the standard which is used in case of both alpha amylase as well as in case of our PPAR gamma protein. Then we went for the molecular docking studies using human pancreatic alpha amylase enzyme with the PDB ID 1B2Y, wherein our molecule E, it is the 5th molecule, showed a comparable binding energy as compared to the standard acaribose, that is less than that, but a similar one with a strong hydrophobic and electrostatic interaction for the alpha amylase inhibition. When we look down for the PPAR gamma binding domain with the PDB ID 2P4Y, we could find out that our molecule, that is E molecule, had better binding affinity compared to the standard, that is pioglitazone, which was used. So therefore, what did we do? We took these molecules and we checked their EDMET properties, which showed that these molecules were non-toxic. And then we moved on to the synthetic methodology. We started synthesizing these molecules with a simple and friendly method. We didn't use any harsh chemicals. We started simply with the 2-imidazole carbaldehyde, and we did Novogel condensation using acrylonitrile. Then the nitro group of this acrylonitrile was reduced using our iron and ammonium chloride reduction, and these amine group was further converted into a Skiff base. These were confirmed using the spectral characterization using the proton, C13, mass, and the FTIR spectroscopy. Then further moving, we moved on to their anti-hyperglycemic activity, wherein when we had the standard, which was E, our E molecule had good binding affinity in the molecular docking studies. In the in vitro studies also, this molecule, that is E, had a comparably good activity when you compare the standard acaribose. It was having 144.7 microgram per ml, whereas our acaribose was having 89. Initially, the 5 selected derivatives, among the 5 selected derivatives, our molecule E showed the comparable results in vitro as well as in silico. And then we did up the glucose uptake assay. Here also our molecule E has shown good activity. Then, along with the anti-hyperglycemic activity, managing diabetes, we have to even manage the oxidative and inflammatory complications coming along with it. So we did the in vitro antioxidant as well as anti-inflammatory activities. The in vitro antioxidant activity was done by 3 methods, that is DPPH, ABTS, and phosphomolybdenum assay. Along with this, all 3 assays when we do, our all 5 derivatives have shown comparable results, meaning that these molecules are having comparable efficiency and they are showing similar activities in all the assays. When we did the anti-inflammatory assay using the albumin denaturation, we found out that our compound C, with having halogen group, has shown good activity, and our compound E, as usual also, it has shown good activity. This means that the observed binding and inhibition of we have taken BSA, that is bovine serum albumin, for denaturation. This means the study also showed that this can be also applied to the human serum albumin, facilitating the blood, facilitating the control of the inflammation in the blood. In conclusion, I would like to tell that Our approach was integrating computational and experimental methodology to provide evaluation of therapeutic potential, and we have succeeded in it. Initially, we have done the molecular docking study, and then we went for the synthesis of these molecules. Our compound E has given potent anti-hypoglycemic agent. It acts as it may act as an anti-hyperglycemic agent with further modifications because it is having good PPAR gamma activation capacity. Then in terms of the pharmacokinetics, our molecules have high GI absorption and they do not show any toxicity, which demonstrated blood-brain barrier permeability. So in the case of efficacy and safety also, the derivatives are good. And by further modifications, we can tell that these molecules can act as good anti-hyperglycemic agents. Thank you, sir.
Okay, thank you, ma'am. Nice
Thank
presentation.
Thank you, sir.
What about your docking score?
Our docking score I have presented, sir. They have shown comparable docking studies.
Okay, okay, ma'am.
Yeah, sir. With the
Thank you very much.
comparable. Yeah, thank you.
Okay,
Sir.
okay, ma'am. Nice. Thank you very much.
Thank you. Sir.
Can I present now?
Next presenter is OP number 35, Madam Fella God. Madam Fella God, are you
Sir,
ready?
excuse me, sir. This is Chitra Devi. We will present here, sir.
Oh, please wait, ma'am. Please wait.
Okay, okay, sir.
OP number 35, Fella God. Okay, absent. OP number 17, Madam Chitra Devi. Please share your screen.
Yes, sir. Sir, visible the screen, sir?
Yes, ma'am. Yes. Please
Oh,
present.
okay, sir. Thank you, sir. So, the very good afternoon, sir. This is Chitra Devi from Assistant Professor of Chemistry from Oasis Institute of Technology. To you, sir. My topic is sustainable microwave assisted green synthesis of magnesium oxide nanoparticles for rapid photocatalytic degradation of toxic dyes. The industrial wastewater contains hazardous dyes such as methylene blue and crystal violet. They are persistent and toxic and resistant to biodegradations. The conventional treatments methods are shown the poor efficiency. So the catalytic reductions are used in the powerful. They are clean the wastes and the powerful approaches and transforms the dyes molecules into less toxic, simpler compounds using light activated catalysts. Then they are taken the magnesium oxide nanoparticles or attractive photocatalysts. They are such as high surface area and stability and excellent electron transfer properties. And they are very effective of the reduction of methylene blue and crystal violet. Then green synthesis using plant extracts provides a safe, eco-friendly. Then microwave assisted synthesis ensure rapid uniform heating, yielding crystalline magnesium oxide nanoparticles in minutes with a minimal energy consumption. This sustainable strategy supports efficient photocatalytic reduction of methylene blue and crystal violet. The promising solution for environmental begin wastewater treatment. The materials and method: preparations of plant extract. Fresh plant papaya leaves washed thoroughly with distilled water, then dried and powdered. Then taken the powder with boiled in 100 ml distilled water up to 15 to 20 minutes. Then cooled the room temperature and filtered. The filtrate was stored in 4 degrees Celsius. Then reducing the this is used for biogenic reducing or capping agents are used. Next, microwave assisted synthesis of magnesium oxide nanoparticles. Then aqueous solution of magnesium nitrate is mixed with the plant extract. Then ratio for 1:1 ratio. Then under stirring. The results mixtures transferred the microwave reactor. Then irradiated at a power of approximately 700 watt for 5 to 10 minutes. Then cooled. Next, the precipitations are observed. The precipitate was cooled and centrifuged with repeatedly washed in the distilled water. Then added to the ethanol to remove the impurities. Then dried at 8 degrees Celsius for several hours. Then finally calcination is carried out for muffled furnace up to heat in a 400 to 500 degrees Celsius for 2 hours. Next, finally, obtain the crystalline magnesium oxide nanoparticles are obtained. For the studies are carried out in the nanoparticles. First one is the UV visible spectroscopy, then FTIR spectroscopy, DLS studies, and XRD analysis. Finally, photocatalytic degradation studies are carried out. The first one is the UV visible spectroscopy and bond gap. The UV visible spectroscopy for the diffraction spectrum, and then magnesium oxide nanoparticles showed the strong absorption UV region. And then absorption is around the 200 to 220 nanometers are obtained. Then the band gaps are approximately 5.0 to 5.3 electron volt. Then the magnesium report the magnesium, they are shown to the peaks are magnesium oxide nanoparticles are reported. The large band gap of pure is shown to the pure magnesium oxides are not in the absorbed in the UV visible light. So they are considered into the photocatalytic activities are under visible light. Next one is the FTIR spectroscopy studies. Then the first one is the FTIR spectroscopy in magnesium nanoparticles are exhibit to the absorption band. Then up to the ratio the band near approximately 550 to 580 centimeters. Then characteristics of magnesium oxide, stretching vibrations confirming the formations of magnesium oxide. The broad band around is the 3,600 centimeters. The surface bond corresponds to the surface OH groups and absorbed moisture water. Next, residual organic moisture are obtained or carbonate species formed during the calcination process. So the presence of surface OH groups are contribute photocatalytic activity. Then facilitating the generations of hydroxyl radicals. Next is the study for the dynamic light scattering. There is measurements of magnesium oxide nanoparticles suspensions indicated to hydrodynamic dynamic diameters distributions centered around 80 to 110 nanometer. Totally reflections some aggregations in aqueous medium. Then next study for the XRD analysis. XRD analysis is the green synthesis nanoparticles shown the numerous diffractions 20 range, that is 50 to 70 ranges. The most reflections 20.28. Then the diameter for 4.37 diameters are shown. Next one is the preferential orientations, the indications for the good crystallinity, additional reflections, some other reflections are forming. Next, the nature of the format.
Madam, move to conclusion.
One second, sir. The next one is the important study for the photocatalytic degradations for a methylene blue and a crystal violet. So there's an important study for the dyes. So using the reduce the wastages in the using in the element. Next, for my conclusions, magnesium oxide nanoparticles are successfully synthesized in the sustainable microwave assisted green root using papaya plant extract. The method proved to be rapid, energy efficient, and environmentally friendly, yielding highly crystalline, uniformly dispersed magnesium oxide nanoparticles. Characterizations on the structure and sustainable suitable optical properties for photocatalytic applications. Green synthesis magnesium oxide nanoparticles demonstrate excellent photocatalytic performance in the degradations of methylene blue and crystal violet. Already I told us the study for the degradations of the methylene blue and crystal violet in the study for photocatalytic degradation is one of the important studies in the method. Next one is the there give out the small size surface hydroxyl group and enhance the charge carrier separations. These finding underscore the potential of microwave assisted green synthesis as a sustainable strategy for producing efficient, cost effective photocatalytic for environmental remediation and wastewater treatment. Thank you for the wonderful opportunity for the Jamal Mohammed College and the host. Thank you, sir.
Thank you, ma'am, for your nice presentation and nice work.
Thank
you
you,
have
sir.
selected magnesium oxide based nanoparticle. Is it correct, ma'am?
Yes, sir.
What is the speciality? What is the speciality of magnesium oxide based nanoparticle?
Magnesium
Other.
magnesium oxide nanoparticles are very reduction capping agent and reduction the wastewater treatment method using, sir. So I easily selected the magnesium oxide, sir.
Which is used as a capping agent for the preparation of magnesium based nanoparticle.
So clearly, hello.
Which is used as a capping agent.
Capping agent, so using the solvents, that is methylene blue and crystal violet are using the biodegradation resistant for the capping agent, sir.
Okay, thank you, ma'am. Thank you.
Okay, sir. Thank you, sir.
Dear participants, we are moving to the conclude the technical session 2 with a vote of thanks. Technical session 3 will start very soon. Dear participants, you are requested to stay back in the same link. Dear participants, you are requested to stay back in the same link. May I request Dr. M. Varisi, Assistant Professor of Chemistry, to propose a vote of thanks. It's a great pleasure for me to propose a vote of thanks. First, I thank the MAT for this great briefing on this special day. On behalf of organizing committee, MAT's regards and hearty thanks to our management and principals for their kind supports. Thank you, sirs. Next, I thank the special opportunity our head of the department. I thank my sincere gratitude to Dr. H.P. Nagasurappa, an alumnus of our college, for serving as judge for today's whole presentation. We truly appreciate your time, your insightful evaluation, and the value of the brought of this section. Thank you, sir. I also thank Dr. Annasandik sir, Dr. Musabargani sir for this support, guidance, and commitment throughout the event. Thank you, sir. Finally, I thank every presenters and participants for your presence and cooperation. Thank you, one and all. Thank you, sir. I kindly request the batch 2 presenters to be prepared for your turn. I kindly request the batch 2 presenters to be prepared for your turn. Kindly stay back here. We will start soon the technical session 3.
No.
In those days, so what is that? Library is very important, books are very important.
Useful session. In this juncture, I welcome Dr. B.M. Praveen, Director, Srinivas University, Mangalore. Sir has total experience of 20 years of experience, and he has published 80 papers and 5 patents, and he guided more than 8 PhD scholars, and still he is guiding 4 scholars. We are very much delighted to welcome our director, sir, to joining in this valuable session. Sir has served as a resource person for more than many programs. With the best of his details, we welcome you, sir. I also welcome the participants, my fellow colleagues, to attend this session, and I also welcome. Once again, I welcome our head of the Department of Chemistry and the Deputy Controller of Examination, Dr. Jafar Ahmed, sir, for engaging this session. Please, sir. Participants, you can present now. Jim Livingston. Are you here? Bisma Farooq. Motipal. Kavya.
Yes, sir.
Yes, sir. Okay. You can present now. You can give a presentation 10 minutes, sir, 5 minutes, sir. Within 7 minutes, sir.
Yes, sir.
2 minutes for question session and 5 minutes for presentation. Please.
Is my slide visible, sir?
Yes, yes. You are not visible, but you are okay. It is visible.
Good evening to all. I am Kavya R. doing PhD under the guidance of Dr. B. Kanchana ma'am, and my research topic is engineering Ni2 complex of pyridine-2,6 dicarboxylic acid and methyl carbazate for energy storage application. Introduction. Metal complexes, due to their unique electronic and structural property, they find application in various fields including medicine, catalysis, and material science. And due to their unique redox property, they find wide application in energy storage system. For the preparation of such unique metal complexes, we have chosen pyridine-2,6 dicarboxylic acid and methyl carbazate as ligand. Pyridine-2,6 dicarboxylic acid is a versatile tridentate ligand. It is capable of coordinating through its 2 carboxyl group and pyridine ring nitrogen, and methyl carbazate has strong donating groups like 2 and CO group, which are capable of coordinating with metals, forming a stable 5-membered metal chelates. Experimental methods. Our objective is to prepare a novel nickel metal complex using pyridine-2,6 dicarboxylic acid and methyl carbazate ligands, and to characterize it using a UV visible FTIR, mass TGDT, single crystal XRD, HF, and DFT studies, and to evaluate its electrochemical supercapacitor performance. For the synthesis of NiPd MCZ metal complexes, initially pyridine-2,6 dicarboxylic acid and methyl carbazate was dissolved in 20 ml distilled water by heating it in a water bath, followed by the addition of 10 ml aqueous solution of nickel nitrate hexahydrate, which was heated at 90 degrees Celsius for 3 hours in water bath until the volume was reduced to 1/3 of its initial volume. And the resulting clear greenish blue solution was left aside for crystallization in room temperature. After 1 week, well-defined bluish green block-shaped crystals of NiPD-MCZ was obtained. Results and discussion. The structure was confirmed using FTIR, UV visible, mass, and TGDTA studies. In case of free acid, the carboxylic OH stretching appears at 3072 centimeter inverse, whereas in case of free base, the NH C double bond O and NN stretching frequency appears at 3200, 1700, and 1060 centimeter inverse. Whereas in case of metal complex, such a stretching frequency is lower, indicating the coordination of C double bond O and NH2 group of methyl carbazate to Na metal center. And additionally, OH band was appeared at 3400 3500 centimeter inverse, indicating the presence of coordinated water molecule in the metal complex. From the UV DRS spectra, the band at 270 and 370 nanometer corresponds to pi to pi star and N to pi star transitions, and additional band around 640 nanometer corresponds to triplet A2G to triplet T1G transition, confirming the octahedral geometry around nickel center. From mass spectral analysis, the peak at MZ value of 333.99 centimeter inverse matches to the molecular weight of the complex 331.9. And from TGDT analysis, the thermal decomposition behavior was analyzed, and the NiPDZ complex was found to undergo 3-step decomposition process. In the first step, it results in the loss of water molecule, and in the second step, it results in the loss of MCZ molecule, leading to the formation of metal carboxylate. And in the third step, in the temperature range of 300 to 400 degrees Celsius, the metal carboxylate decomposes to form a stable nickel oxide as the end residue. From single crystal XRD, the single crystal XRD analysis was performed to confirm the structure of NiPD-MCZ complex. The NiPD-MCZ complex crystallizes in monoclinic crystal system in CC space group. In the RTEP diagram, the asymmetry unit consists of 2 independent monomeric units, where pyridine 2,6 dicarboxylic acid is coordinated through its 2 carboxyl oxygen and pyridine ring nitrogen, and methyl carbazate is coordinated through its NH2 group and C double bond O group with the additional coordinated water molecule, confirming the 6 coordination geometry. The packing diagram shows the existence of 6 monomeric units per unit cell, and the presence of various inter and intramolecular hydrogen bond interaction leads to the formation of stable 3-dimensional structure. From the Hershey field surface analysis, in DNAM, DI, and DE, the intense red spots were found in the carboxyl oxygen atoms and carbonyl NH2 group of methyl carbazate, serving as the evidence for the existence of OH1 NH1 hydrogen bond interaction. Shape index, cloudiness, and the fragment patch, the adjacent blue and red triangles, the flat green areas and large fragment patches shows the existence of pi stacking interactions in the crystal. And further, from DFT analysis, a low HOMO-LUMO gap of 1.088 electron volt was determined, which is found to be very low, indicating efficient electron transfer in the complex, leading to enhanced reactivity, less stability, and the molecule was found to be soft. Electrochemical supercapacitor application was NiPD-MCZ complex. From the electrochemical impedance spectroscopy, a low charge transfer resistance of 0.56 ohm was determined, indicating the excellent electrical conductivity of the compound. Further, the cyclic voltammetry was carried out in the potential range of 0.2 to 0.63. The analysis of a CV profile shows that the analysis of a CV profile of bare nickel foam and NiPD-MCZ coated nickel foam shows the enhanced contribution from NiPD-MCZ complex. Further, the deviation from regular
conclude session
shows the pseudo-capacitive behavior of the complex. Sir?
Kavya madam, you conclude your presentation because okay, time is only 5 minutes. More participants are waiting in the lobby.
Yes, sir.
Okay, your work is very nice.
The GCD test was performed and high specific capacitance of 409 F by G at 1 ampere per gram was determined. On concluding my work, a novel nickel coordination complex was synthesized using pyridine 2,6 dicarboxylic acid and methyl carbazate ligand using a slow evaporation technique, and single crystal XRD confirmed its octahedral geometry with showing that the crystal crystallizes in monoclinic crystal system with CC space group. The octahedral geometry was satisfied by diionic PD ligand, neutral MCZ ligand, and 1 coordinated water molecule, and a low HOMO-LUMO energy gap suggests the enhanced reactivity of the compound, and the electrode exhibited an impressive specific capacitance of 409 F by G at 1 ampere per gram, with very high energy and power densities at 136.2 watt-hour per kg and 27.8 kilowatt-hour per kg.
Okay, we'll move. Okay. There is any question from the student side? You can raise your questions. Okay, thank you, Kavya. Your presentation is very good. I think you have presented in a PhD Viva was because you have a lot of work. I congratulate. Thank you. Thank you. Next, Motipal, are you in the lobby? Motipal.
Yes, sir. Yes, sir.
Okay. You please start the session.
Yes, sir.
You have to conclude within 5 minutes.
Yes,
because
sir.
the time is very short. Okay.
Sure.
Please.
I'm sharing the screen. Sir, are you able to see my screen?
No, sir, it's not shared.
Okay.
So go. Lobby go on. Sir? Sir,
Taking some time. Maybe someone else can present. So I will join.
Okay. We'll pass to another participant.
Yes, sir.
Shasbank. Shashak. Are you here? Shashak. Ramar Marimuthu. Kesavan Devanarayan.
Sir, I am here, sir. Ramar Marimuthu.
Okay. You please present.
Yes, sir.
Okay.
I'm sharing my screen. Hello.
Yes, sir.
Sir, my screen is
Sorry, sir.
No,
not visible.
Wait a minute, sir. It is sorry. It is visible, sir.
Okay. It is visible.
Okay. So good evening, everyone. I am Dr. Ramar Marimuthu, as working as assistant professor, Tamil Nadu Dr. J. Jilla Fisheries University, College of Fisheries Engineering, Nagapattinam. Actually, my title is changed in the list. I am presenting my whatever I am submitted my abstract. Evaluation of weight and time and the performance of crustacean cell based isolating energy harvesting tiles.
So the question is small. Question
Audio வரலீங்களா?
Where particularly? Colorimetric.
இதுதான் சார்.
நான் சொல்றேன்.
Sir, hello. Sir.
Title is not.
Yes, sir. Actually, I already informed to the concerned person, sir.
Okay, no problem.
Okay.
Yes, sir. My title of the presentation is evaluation of weight and time and the performance of crustacean cell based piezoelectric energy harvesting tiles. Actually, what we have made, we made from our the crustacean cell waste, we made the piezoelectric material. From that, we can have some small devices made. That device, it is put in the tiles type. We have some tile type. We will discuss on this presentation. Okay. This is the content of the project. My paper. Actually, the introduction of the paper is the cetine occurs in the variety of organism in aquatic ecosystem. It is the second most abundant natural polysaccharide after cellulose and present in the crustacean, insect and fungi. The up to date, the main commercial source of cetine is our shrimp and crop cells, because lots of waste are generated in every day, and that wastage we can use as a energy sources. The crustacean cell industry generates a huge amount of cell waste for processing the environmental nuisance. Alternatively, this waste can be utilized as an energy harvesting energy applications. And shrimp and crop cells have the piezoelectric property, which can be utilized by using piezoelectric tiles that harvest the energy in the using the food step. This power generation from food step is one of the most important activities in the normal human life. It is food
Sir, you
stepping,
please
because
go to
every
the
day we are
materials and
walking.
methods.
Rama sir.
Okay.
You go
This
to the
okay, sir.
experimental part.
Okay, sir. The subject of the paper is to develop a piezoelectric energy harvester from the crustacean cell to check the piezoelectric tiles performance and efficiency. This is a methodology. We are collected from the crustacean cell waste from nearest harbor and processing unit. And first we made the pre-treatment treatment, and the second demineralization process. Third one is deprotonization. Finally, we will get the flexible and transparency of the piezoelectric materials. This is a processing of materials. This is a crop cell, this shrimp cell, and we give the chemical treatment, and finally we will get the transparency and flexible substrate. This is, it will rotate in 360-degree also. We made some we given the some contact that it converted as a small device. This device can be used as the piezoelectric tiles. This is the design of the piezoelectric tiles. We have top and bottom we have a acrylic sheet, and top and bottom we have a foam sheet, and inside this 4 line is our device. This acrylic sheet have a 6 mm thickness, and the foam sheet have a 2 mm thickness, and finally our device is ready. This is tiles of one device, one tiles of 1 into 1 square feet tiles. And we have done the time versus and with the weight percentage. We have done this type of experiment. It's 10 minutes, 20, 30, 40, 50, and 60 minutes difference. We have that is hugely increased whenever we are increased the time, and the voltage also increased. Based on this, we have done the different type of weight concentration. This is a weight percentage. 40, 50, 60, and 55 kg also. It is see all the different of 10 and 20, 30 minutes difference, and the 50, 60 minutes difference also. This finally we observed the 60 kg percentage of weight is giving the more voltage compared to the other weightage from this piezoelectric tiles 1 into 1 square feet. This already patented and granted also last year, and we got the from the certificate also for the granting of patent, recent patent. And conclusion of the work is the piezoelectric material are connected in the series mode, producing high output voltage. The electricity was generated from shrimp and crop cells with the pressure electric properties using a series circuit. The different amount of electricity were taken from the 40, 50, 55, 60 kg. Total 6.5 voltage we got the within half an hour. The percentage of 60 kg weight. This piezoelectric tiles have the potential to be used as a green energy harvested from human foodstuffs. Thank you, sir.
Questions? Question.
Thank you very much, Mr. Ramar Marimuthu, for your wonderful presentation.
Okay, thank you, sir.
So we have a few clarification regarding your presentation.
Okay,
your
sir.
tile is entirely made up of that shrimp and crab
Yes,
shell
sir.
powder,
Yes,
right?
yes, yes, sir.
Have you used any binder, or entirely it is made up of these two stuffs only?
Sir, we made only from that crop cell and shrimp cell only we have used, sir.
Okay.
For that material, that cell we can convert it as a piezoelectric material. Some chemical processor we made. That is why we have this type of process. 4 steps. This is pre-treatment, T mineralization, we will remove the the mineralization material, and protonization also we
In
can
methodology, you have included a term called processed prawn and crab.
Yes, sir.
So,
Processing means
have
the
you
methodology.
had any binder like calcium carbonate, plaster of Paris, like that?
No. So we some chemicals only I have
Yes. Okay.
included.
This is patented work, right?
Yes, sir. Patented, sir.
What is the dimension of your tile? A single tile.
1 into 1 square feet, sir.
Square. Approximately it weight about?
Weight about 250
So you have
kg.
mentioned in your conclusion that 40 kg, 55 kg.
No, that is pressure, sir. What actually the piezoelectric material have? What is the main piezoelectric effect means whenever.
Yes. That was I am asking. Have you weighed your tile, a single tile?
Yes, sir. Single tile. That is why this type of different type of person we can walk, sir. Through the weight percentage, 40%, 45%, 50% kg, and
so depending
60 kg
upon the
also.
pressure, you get the variation in the amount of
the voltage, sir.
right?
Yes, sir. Yes, sir.
Okay. Thank you.
Actually, this can be fitted in anywhere and wherever it is more people are walking, like railway station.
We can fix it in the mall and walk area so that.
Yes, sir. We can get the more electricity. Sir.
Okay, thank you. Thank you very much.
Thank you.
Motipal?
Yes, sir. I will try now.
Okay.
Sir, is my screen visible?
Yeah. So I think you are presenting from your mobile, right?
Yes.
Just maximize, zoom in your type. Slide. Yeah, it's okay. Little bit smaller. Yeah, it's okay. Okay, now it's fit. Okay.
Okay, sir. So I will start. Good afternoon, everyone. My name is Dr. Motipal. I'm from PSN College of Engineering, Tirunelveli. So today I'm presenting a work on triazine substituted with flexible pyridyl arms for metal organic frameworks. So these are all the ligands that we have synthesized. So MOFs are a Nobel Prize work. We have recently received Nobel Prize, and they are used to make different materials that have pores in it. They are used for gas storage, separation, sensing, and in order to construct metal organic frameworks, we need a linker ligand that has multiple coordinating sites in different parts. Generally, MOFs are prepared using rigid ligands. But more often in these days, nowadays, people are trying to focus more on flexible ligands so that when the guest binds, there will not be much difference. So the overall structure can adjust itself for guest binding and release. So with this idea in mind, we decided to.
So just go for the technical session, please. Materials and methods and your characterization.
Yes. So synthetic route is shown here. The starting material is from cyanuric chloride, which can undergo nucleophilic substitution in a temperature-dependent stepwise manner. So piperazine contains two NH groups, so one of which has been protected with a Bock protecting group. So then we substituted the chloride groups in piperazine, and then we made a dry substituted starting material. So with this starting material in hand, we then tried doing a coupling reaction with amides to form amides. And this reaction is carried out using a coupling reagent called DCC, dicyclohexyl cyanamide. And in the presence of a base in dichloromethane at 0 degrees, it goes through the room temperature at 16 hours. We get this compound, which is tri-substituted. This compound has nitrogen at one end, and there is an amide group and triazine ring in the core. So we have prepared 3 molecules here, 2 pyridyl, 3 pyridyl, and 4 pyridyl ones. So we have characterized these molecules using proton NMR, IR, C13 NMR, and mass spectroscopy. So all the results we have got, which corroborate with the structure. I will just briefly show some of the results here. So the proton NMR shows clear peaks for pyridyl groups and also for the piperazine unit. And similarly, the IR spectra shows C double bond O, C double bond N, CN stretching frequencies. For each group, we have done all these studies, and we have concluded that the mass spectra clearly shows only one peak corresponding to the formation of the product. So with this product in hand, now our aim is to carry out the reactions with metal so that we can construct metal organic framework. So in conclusion, 3 new ligands have been synthesized. These ligands show flexibility and they have 120 degree spatial orientation, which can provide an excellent platform for 3-dimensional propagation of MOFs and COFs. They are covalent organic frameworks. This reaction uses a simple starting material called cyanuric chloride. From that core, we started out and we made a complicated, an elaborate ligand system. It has been fully characterized by IR, proton and synthetic NMR and mass spectral methods. Now this will be carried out to do MOF studies. Thank you very much. If you have any questions, I will be ready to answer it.
Why don't you include the spectra of the compound in your slides?
Yes, sir. I have included. It's raw scanned image. So I have just kept it in the last slide. I'm showing it here. So this is the proton NMR spectra. So all the
what is the
CH2
solvent you
groups,
have? What is the solvent you have employed for this?
Solvent is CDCl3. I mean CDCl3.
CDCl3.
Yes.
Okay. What is your synthetic pathway?
A synthetic pathway is it starts with nucleophilic substitution, and then second reaction we have used.
It is noticed from your slide that it undergo elimination reaction in the initial step. I think so.
Yes, sir. It's actually a nucleophilic substitution, starting with cyanuric chloride. Chloride is substituted, and the nitrogen goes there.
Okay.
Okay. Okay. Thank you.
Okay, sir. Thank you very much.
Anand Devi. K7 Devanarayanan. K7 Devanarayanan.
Yes, sir. Available, sir.
Okay.
Okay, you can start.
Good evening, ladies and gentlemen. Myself, Dr. Kesavan Devarayan from College of Fisheries Engineering, Tamil Nadu, Dr. J. Jayalalitha Fisheries University, Nagapattinam. The present work is about the design and development of an edible bioplastic packages for food application. Basically, we all understand that fish is a highly nutritious food. It offers numerous health benefits. Still, the working population do not find any time for purchase of the fishes, cleaning of them, processing of them, and then cooking them. So there is a upcoming concept called as a ready-to-cook type of protein-based food. When we talk about the fresh fishes, ready-to-cook type is yet to reach the market or get the consumer acceptance. Still, there are other fishery products like dry fishes and also fish soup powders, which gets attention from the consumers. But these products need very good packaging, different from other normal materials. Here.
Yes, sir.
Yes, sir.
Mainly materials, madam.
Yes, sir. Yes, sir. I'm moving on to this.
It is better.
So this yes, I understand. Okay, 3 key points. First one is we want to develop a film, packaging film that has biodegradability and edibility, along with the sense of detecting the spoilage within the package without opening the package. Because when we talk about the packaging material, we cannot find the spoilage without opening the package, but we have introduced a concept which can show the spoilage without opening the package. This is the methodology how we have prepared the packaging material. We mixed the biopolymers such as hydroxyethyl cellulose, water-soluble chitosan together and starch together to form a mixed indicator to form a film, neat film. This is the scanning electron microscope morphology of the thin film and UV visible spectrum of the film, and the average thickness of the film was 0.3 millimeter, and the FTIR spectra also confirmed the successful preparation of the packaging material. This is the tensile strength result of the packaging material. In fact, here we could see that the tensile strength is about 130 kg per square centimeter, which is almost comparable with the commercial low density polyethylene, which means that this packaging material could be useful for the commercial applications. And we also checked the sealing property of the packaging material, because when we talk about the packaging material, most of them do not come with the sealing property, but ours showed excellent sealing property at all temperatures. We extended the application to the food materials like peanut candy, chocolates, and fish soup powder. In fact, our packaging material shows transparency about 85%, which is really good for consumer acceptance for a packaging material. And we tried to make the soup out of the packed soup powder. It's like a tea bag we find in the railway stations, or the green tea bag we use is a kind of a dip and drink type. So we prepare this package, simply dip into the hot water, wait for 30 seconds, you get the soup, nutritious soup. That's the key point here. And we also checked the hemolysis, biocompatibility by means of hemolysis. Only then we can truly show that this is a biocompatible edible package. The material showed a good biocompatibility. Usually a biocompatibility value less than 5% is usually acceptable as a biocompatible material, edible material. We tested the biodegradability by means of soil test. Within 2 weeks, we find no remnants of the film left out in the experiment, and the Solling index also we couldn't find any remnants because it's a highly water soluble film. And we checked, we wanted to confirm our results along with the conventional biochemical methods such as total volatile base nitrogen and microbial analysis along with the sensory evaluation. In fact, here we tested the sensing ability of the package towards the total volatile base nitrogen, because protein-based foods like fish releases total volatile base nitrogen compounds when they decompose. So we incorporated the indicators into the packaging material so that it can show the spoilage. As we can clearly see that 0 day it was around a yellow color, and after almost 4 months of storage it showed like the orange color, which is in line with the spoilage of the packed fish soup powder. And this is the summary and conclusion. Finally, I would like to say that we have developed a highly biodegradable and edible packaging film, which can be used for making of ready-to-cook type of fish soup powder. And also, the application of this package can be extended to the other fish food products like chocolate, peanut candy, among others. And I thank the funding agency for the financial support. Thank you very much, sir.
Thank you, sir, for your nice presentation. I
Yes,
think
sir.
you have checked the degradation of your edible package in soil testing.
Yes, sir.
Is it resistance to water? Have you checked this water resistance of your package?
No, sir. This package is completely soluble in water, sir. That
So
is why
if
we
it
were
is,
able to make the fish soup, sir.
So if it is a water resistant material, we can consider it as an alternative to the plastic. Okay, sir. I will hope you will develop this in future. Thank you very much.
Yes, sir. Thank you, sir. Thank you very much, sir.
Mr. Anand Devasigamani.
Yeah, available, sir.
Yeah, you can start.
Yeah, thank you, sir. Now, my screen visible, sir? Yeah, can I start, sir?
Yes,
Yeah.
Yeah. Myself, Dr. Anand, Associate Person Head in Department of Aquatic in the TNJIP Nagapattinam. So I am going to present the nutrient dynamics, water quality, and the population effects of coffee pods by using fermented rice bran sources in the coffee pod production systems. So the copepods are the most abundant metashawarms on the earth and form nearly 80% of the marine zooplankton biomass. And they are serving as first food for the crustacean larvae due to its high DHA, EPA, and ERA content. So the present study used the Ithona and Aphocyclops species since its nutritional contents. So the methodology, study location was Mandapam Center for Sustainable Aquaculture, and the excluded design completely randomization, 4 treatments into 3 replicates, that is 12 apartment tanks having 200-liter capacity. The duration is 10 days, and species used were Ithona species and Aphocyclops species. So there were 4 treatments. T1 is fermented rice bran, T2 is fermented wheat bran, T3 is fermented mixer bran, and control is microalgae as usual. They are doing in the hatcheries with the Anapleurus species. Fermentation is done with 200 grams of bran plus water plus commercial probiotic containing bacillus species. Fermented 24 hours with the aeration at pH 6 to 7 and 29 degrees Celsius. So the uniqueness of this particular study is earlier studies were used only the carbon sources, whereas here in this particular study we have fermented the brans like rice bran, wheat bran, and the mixed of both these things and a separate control. And again, the fermentation was done using a bacillus bacteria. So this is the uniqueness of this present study. And culture procedure, the tanks were disinfected, filled with the filtered UVC water. Copepod stocked at a cell density of 20 individuals per liter. Fermented rice bran was added at 3 ml per liter every day, and the water quality parameters are monitored every day. So Copepod cell density also counted every day using Celsius data cell. So the results and key findings are like temperature maintained at 28 degrees Celsius, salinity almost 33 ppb, and pH between 7.1 to 8.7, remained with optimal ranges for all the treatments. And again, in the rice bran treatments, it maintained a very good water quality comparable to the control. So wheat bran and mixer bran showed elevated ammonia, nitrate, and phosphate levels, indicating slower decomposition. And Copepod cell density that was measured after 10 days, like T1 rice bran with 190 individuals per liter, that was highest. And control microalgae followed by control microalgae, that is 124 individuals, and T3 mixer bran with 121 individuals, and T4 wheat bran 47 individuals only. That is the lowest actually. So rice bran was the most effective substitute. And the water quality parameters like showing dissolved oxygen in the rice bran, wheat bran, mixer bran, and control. So this temperature maintained remain 27 to 27.1. Salinity remained between 32.7 to 32.88, and ammonia recorded lowest in the case of rice bran. Again, nitrate and nitrate, same thing. It was recorded lowest in the case of rice bran, followed by control treatments. So if you see the Copepod cell density, and the rice bran exhibited the highest cell density, 183 cells in the per liter per ml during the 10 days experiment, and followed by the control, followed by mixer bran, and finally the wheat bran showed the lowest cell density. So the discussion, nutritional richness, the fermented rice bran contains highest protein, essential fatty acids, and more digestible carbohydrates. And the fermentation improves the nutrient availability and reduces the anti-nutrient factors that are in the rice bran, and enhancing the Copepod growth and reproduction. So the better water stability was observed in the case of rice bran treatments, so resulted in a good growth of Copepods. And the practical advantage, it is very cheaper and more easily available than microalgae, and reduce the need for continuous algal production systems. So suitable for scaled for hatchery applications in commercial hatcheries. Thus, the fermented rice bran showed highest cell density with low cost, and it is very efficient in the Copepod production. So conclusions, this study demonstrates that fermented rice bran is the most efficient dietary enrichment among the tested carbon sources for Copepod production, and it yielded the highest population density, maintains stable water quality, and offers a cost-effective alternative to the microalgae. So rice bran can therefore be recommended for routine Copepod culture in marine hatcheries, aiming to improve live feed availability and reduce the operation cost. So further studies may focus on optimization of fermentation techniques, dosage standardization, and long-term impacts of Copepod production. So these are some of the references. Yeah, thank you, sir. Thank you.
Thank you, sir. Nice presentation, sir.
Thank you, sir. Thank you.
Next one, Jannatul Firdaus.
Sir, can you hear me?
Your name, sir?
She is our author, and I am the co-author of the paper. So, can I present, sir?
Jannatul Firdausi.
Hello, sir. I am the co-author of the paper.
Okay, you can start. Okay.
Thank you, sir. My name is MD Abu Taleb. I am from Jahangir University, Dhaka, Bangladesh. Our title is phase separation and UV visible spectroscopic investigation of the clouding, cell assembly, and binding behavior of non-ionic surfactant and biopolymer mixture in aqueous hydrophobic media. So in our study, we use surfactant TX100. It is a non-ionic surfactant, and we used biopolymer sodium alginate. So why it is important to study the biopolymer and surfactant interaction? Because it improves drug delivery and biomedical application. Also stabilize the formulation of drug. Also increases solubility of drug. Before our study, we did some literature review, and I have found there is no work for sodium alginate TX100 and hydrophobic medium. So we are interested how hydrophobes interact with sodium alginate and TX100 media. So our objective was to study the effect of
Please
sodium
go to
alginate with
the
biopolymer.
experimental part.
Yes, sir.
Slightly go to the experimental.
In our experiment, we calculated cloud point using this procedure, and we calculated CMC using UVB spectroscopy method using this procedure. And in our result, we have found the total. We have 6 hydrotopes. We have shown 2 hydrotopes in this graph, and other 4 was shown in this graph. For salicylic acid and its salt, sodium alginate, they show completely different trend. When we increase the concentration of salicylic acid, we see that the CP value gradually decreases. It is because when we add salicylic acid to the medium, it disturbs the hydrogen bond between TX100 surfactant and water. So as a result, the space separation occurs early, and similar trend was followed by chlorine chloride. And for sodium salicylate, when we add it to the solution, we see that it stabilizes surfactant. As a result, the phase separation occurs at high concentration. Similar trend was followed for polyethylene glycol, urea, and nicotinamide. So from there we have calculated the thermodynamics equation, this equation, and we have found that TX100 plus sodium alginate plus salicylic acid in lower concentration, they show the system was non-spontaneous and enthalpy was negative, meaning it was exothermic process, and entropy was also negative, so the system was organized. But as we increase the concentration, we see that the del G is still positive, so the system was non-spontaneous, but the del enthalpy was positive, meaning that it was an endothermic process, and enthalpy was also positive. The system was more disordered. A similar trend was followed for chlorine chloride. For sodium salicylate, urea, nicotinamide, we see that when the concentration was low, the system was non-spontaneous. Also, the enthalpy was positive. The system was endothermic, and the system was also very disordered. But as we increase the concentration, we see that the system is getting more ordered, and we also calculated the CMC using UV's spectroscopic method, and we see that when we have 0.1% sodium alginate and increase the concentration of surfactant, we see the absorbance increases. When we added one of our hydrotopes, urea, we see that the absorbance also increases gradually with TX100 concentration. From there, we have calculated the CMC value. For sodium alginate and TX100, we see the CMC value was 0.435 millimole per kg. But when we added hydrotope to the solution, we see that the CMC value increased. From here, we have calculated the binding constant of TX100 and sodium alginate, and we see that when we added urea to the solution, the binding constant increases. So the interaction between sodium salicylate and TX100 increases when we added urea to the solution. Also, we see that partition constant also increases. So the sodium alginate favors to a state in the micellar form. Also, the system was spontaneous. So from our research, we found that sodium salicylate, polyethylene glycol, nicotinamide, and urea all showed higher CP value. On the other hand, salicylic acid and chlorine chloride show decreased CP value. Also, the system was non-spontaneous during clouding. Also, both hydrophobic and electrostatic interaction in the TX100 and sodium alginate mixture are shown by positive and negative values of enthalpy and entropy. And also, the CMC is increased in the presence of hydrotopes. And the partition as well as binding of TX100 and sodium alginate is a spontaneous process, indicating by the negative value of free energy equation. Thank you, sir.
Thank you, sir. Nice presentation. Thank you. Next one.
Yes, sir. I am available.
Arvind Radha, you can present.
Yes.
Please conclude within 5 minutes.
Sir, my slide is visible.
Plus minus.
Good evening, sir. Myself, Radha Arvind. Currently, I am doing PhD degree in NTUT, Taiwan. Today, I would like to present my topic on lanthanum stannite and functionally CNF nanocomposite towards the detection of TBHQ analyte. And here I am choosing that electrochemical sensor for a TBHQ analyte. Here I am choosing rare earth stannite and functionally CNF towards the detection of TBHQ analyte. For material preparation, here I'm using hydrothermal synthesis. For preparation of lanthanum stannite, the starting precursor of lanthanum nitrate and SnCl4 stirring for 15 minutes. After complete the reaction, I'm adding CTAB for the nucleation and also the growth of stannite particles. After complete the process, I poured into autoclave and heated up 160 degree and 16 hours. And after that, I fabricated on a GCE electrode to detect that TBHQ analyte. And for the confirmation of lanthanum
Madam,
stannite
kindly discuss your result and conclusion.
Discussion. Here.
The time is very short.
Yes. Okay, sir. And here I comparison of TBHQ analyte with as represented previous literature. Based on this, compared to other studies, and I got the good LOD value and also the high response. And based on this, fabricated electrode of lanthanum stannite and functionally CNF using hydrothermal methods is good good fabricated electrode towards the detection of TBHQ analyte, and also it provides that a good linear range and also that good LOD value. Thank you for your attention.
Okay, thank you.
Thank you, sir.
Next one, Jerly action.
Who is available?
Jerly Auxilia.
So can I present?
Who is available? The lobby.
Shokit Hussain.
Yes.
Sir, it's Bisma Farooq.
Yes.
Shokit Hussain
Am I
available?
audible? Am I audible?
Yes, sir. Yes, sir.
Shokit Hussain.
Yes. Am I audible?
Yeah. You can start.
Thank you, sir. Myself, Dr. Shokit Hussain, Assistant Professor in the Department of Chemistry, Government Postgraduate College, Rajouri. Currently, I am posted in J&K Higher Education Department. Today, my research topic is extracellular biosynthesis of silver nanoparticle. One-port chemical reduction method we use to the formation of Ag nanoparticle using aqueous leaf extract of oriental plane. This oriental plane is basically a plant famous in Kashmir, which is known as oriental plane, and it belongs to family of Platanus famila. Paperwork has been divided into following categories: introduction, material used, experimental work, characterization, result and discussion, conclusion, and further future outlook and perspective. This is the introduction. I think I have to skip. These are the nanoparticles span many areas. Main material used in experimental work. First of all, we prepared plant extract. Approximately 10 grams plant extract were thoroughly washed with double distilled water and finally cut into into 250 ml water. Heated the mixture below 60 degree for 30 minutes. Filter through Wattman number 1 filter paper. Then extract solution was stored below 5 degrees centigrade to use for the preparation of nanocomposites. In this process or method, we use silver nitride extract at room temperature, and a preliminary observation shows that the initial color of the reaction mixture after the addition of leaf extract to the aqueous solution, silver nitrate solution, was nearly colorless. Interestingly, the color of the reaction mixture changed from pale yellow, pink yellow, light brown, wine red to dark brown conventionally with the reaction time as aggregation proceeds. This also shows here with times 30 minutes, 60 minutes, 90. These are the UV visible observation spectra. The reaction time curve shows that the Ag plus ion reduced into Ag0.
Okay. Hussain sir.
Yes, sir.
Go to conclusion.
Okay. That the time which is. We report the synthesis of Ag nanoparticle by using oriental plane tube extract as a reductant. CTAB and extract cape Ag nanoparticle have been prepared by using an aqueous leaf extract of oriental plane, silver nitrate, and CTAB for the first time. In this present study, we show that an extract of oriental plant leaf placed in an aqueous solution of silver nitrate, resulting in the reduction of Ag plus ion and formation of stable Ag nanoparticles. The appearance of silver sol, reduction of Ag plus by leaves extract was monitored by UV visible spectroscopy as a function of time with water as a reference. The morphology of Ag nanoparticle was determined by using TEM. The selected area electron diffraction data were also recorded. Samples for TEM analysis were prepared by coating of aqueous silver nanoparticle drop on carbon coated copper grid kept for 5 minutes. The extract solution was removed using blotting paper at room temperature. Finally, we have the future outlook and perspective. The unique physiochemical properties of this biopolymer lead to be used in green chemistry application as non-toxic reductant for metal nanoparticle, as a catalyst, as a biosensor, biomedical, bioremediation, etc. Thank you, sir.
Okay. Thank you, sir. Hussain sir. Nice presentation. Thank you.
Thank you, sir.
Next one, Nivedita, madam. Nivedita.
Yes, sir.
Akhtar Kubai, Nivedita is there?
Yes, sir.
Okay, you can start.
Okay, sir.
Nivedita, are you presenting?
Sir, yes, sir. No, 1 minute, sir.
Shall we pass to other candidate?
Yes, sir. 1 minute, sir. Sir, I have a screen is share, sir.
Okay. Please be in the lobby. After the another presentation, you can present. Okay. Next again.
Akhtar Kubai.
Sir. Sir, screen is share, sir.
No, not visible.
Sir.
Already we are in the late.
Okay, please wait, make your system ready. Mr. Akhtar Kubai. Steve Jonathan. Steve Jonathan. Pavitra.
Pavitra available, sir.
Yeah, Pavitra, you can start.
Okay, sir. The slide is visible, sir.
No. I was saying that mistake.
Is it visible, sir?
Yes.
Yeah.
Thank you, sir. Good evening, all. I am Pavitra, research scholar, Anna University, under the guidance of Dr. K. Jyoti Venkatachalam. Today, I am very happy to present my work entitled Development of Organic Semiconductor Tailored Transition Metal Phosphates for Enhancement of Electrochemical Hydrogen Evaluation and Photocatalytic Pharmaceutical Pollutant Degradation. My work focuses on a single catalyst material that can contribute to both clean energy and clean environment, which are most essential requirements of modern society. The global challenge, the rising energy demand. Hydrogen is a leading clean fuel option due to its zero carbon energy output. However, large-scale hydrogen production requires high efficiency and cost-effective catalyst. This is a major scientific challenge. And expensive, so platinum is the best HER catalyst.
Madam, kindly discuss your findings only, please.
Okay, sir. Synthesis. Here the synthesis route I followed for preparing NiMOP hydrothermal reaction carried out. And then XRD analysis confirmed the formation of NiMOP peaks around 33 and 60° correspond. 111 and 220 plants. No impurity peaks were detected, showing high phase purity. The peak broadening indicates nanocrystalline behavior, which is beneficial for catalysis due to increased active surface sites. And here FE morphology exhibits nanosheet surface texture with aggregated classes. Such morphology offers high surface area, more active catalytic sites. Uniform and dense architecture promotes better charge transfer during catalytic reactions. And elemental mapping reveals uniform distribution of NiMOP throughout the nanostructure. This proves true phosphide formation without segregation. Uniforming ensures consistent catalytic performance and stable reaction sites. Dual functional mechanism for HER for photocatalysis. Both functional we have to do for this material, and further work is composite fabrication with the organic semiconductor and performance testing and mechanism analysis validation. The current progress is successfully synthesized nickel molybdenum phosphate nanostructure with confirmed crystalline phase and nanopetal morphology. Strong foundation established for high performance dual functional catalysis. Thank you.
Thank you. Okay, thank you, man. Thank you.
Niveta.
Kaviyara Silango. Kaviyara Silango. Rati Priya Mahadevan. Meena. A.R. Pavitra. Okay. Marshita Ramesh.
So available, sir.
Okay, ma'am, you can start.
Okay, sir.
Okay.
So is the screenshot?
Yeah, ma'am.
So good evening to all the respected delegates, researchers, and participants. I am Ashwita Ramesh, currently pursuing my studies in the Department of Energy and Environmental Engineering at Tamil Nadu Dr. J. Jayalalitha Fisheries University, College of Fisheries Engineering. Today, I am delighted to share my project work title, Study on Hybrid Raindrop Solar Energy Harvesting Device. So, the total abstract says, solar-only energy systems suffer substantial efficiency loss during energy or overcast conditions. The study therefore proposes a hybrid model that combines conventional solar power with droplet-based triboelectric energy harvesting. The transparent protective layer above the solar cell performs dual functions, allowing sunlight penetration while simultaneously harvesting electrical energy from falling raindrops. So the introduction is...
You go to the methodology.
So therefore, the methodology is, the methodology involves the fabrication of a hybrid device consisting of a photovoltaic layer paired with a transparent triboelectric nano generator, which is the 10G layer. The transparent layer is engineered to maximize sunlight transmission while enabling surface charge accumulation from falling droplets. So therefore, if the rain is present, the FEP sheet is nothing but the fluorinated ethylene propylene sheet. It can generate the electricity when the raindrop is present. And if the raindrop is not present, automatically the sunlight is passes through the FEP sheet and the PV cell generates the electricity. So this is the methodology which is I used. And the overall result said, the developed hybrid panel successfully produced electrical energy from both solar irradiation and raindrop stimulations. The transparent triboelectric layer, FEP fluorinated ethylene propylene sheet, is facilitated dual functionality, uninterrupted light passage, and efficient electrical charge collection from sliding droplets. Therefore, the conclusion is the hybrid raindrop solar device overcomes the limitation of conventional solar panels by continuing to generate electricity even during rainfall. It can be seamlessly integrated onto windows, rooftops, or smart buildings without major modifications. Therefore, this technology emerges as a promising solution for sustainable and continuous environmental energy harvesting in flexible urban settings. Therefore, these are the references. So thank you, sir. Thank you for all your attention.
Thank you. Thank you.
Kannagi, madam. Madam Kannagi from EVR College. Bisma Farooq. Kannagi madam available?
Sir.
Yeah, you can start your presentation, madam.
Okay, sir.
Kannagi madam இல்ல. Gerli Auxilia available? Madam Niveta?
Yes, sir.
Niveta, you can present.
Okay, sir.
Niveta, your issue resolved?
Sir, no, sir.
Okay.
Start your
Sir,
presentation. Your system is
Sir,
not
okay,
working?
sir. Sir, okay, sir. The screen are available, sir.
No, your screen is not visible. Okay, just start your content, no issues.
Cellular one.
Sir, my
Yes.
screen are
Yeah, yeah,
available,
yeah.
sir?
Yes. You can start.
Okay, sir. Good evening to all. Very warm welcome to my oral presentation. I'm Sri Nivetha, research scholar under the guidance of Dr. B. Premlata, Assistant Professor, Government Arts College, Chidambaram. My oral presentation topic is review of 2-hydroxy-1-naphthaldehyde with aniline for energo material. Introduced to 2-hydroxy-1-naphthaldehyde and the issues of the substituted aniline are used in to 2,5-dinitro-anilines are under the SWAT. And then 2-hydroxy-1-naphthaldehyde is a flexible fluorescence, and that the applications are various to biological, chemicals, and medical.
Nivetha, please go to the experimental part.
Okay, sir. And that the scheme of this work is 2-hydroxy-naphthaldehyde and 2,5-dinitro-aniline is dissolved in ethanol to 2 to 3 days to go, and that yellow needle crystals are formed the presence of the E configuration of that product, that is the crystallization, that is the scheme of this work. And the characterization techniques are by this technique, and that IR spectrum of the crystals are shown here, and that IR spectrum presence in the OH hydroxyl group confirmed, but at that 30 IR spectrum of this presence of hydroxyl group was confirmed, but that 3,589.4 centimeter inverse. At that peak of the carbon nitrogen stretching vibration observed at 1,602.6 centimeter inverse, and that H1 NMR spectrum shows the H1 NMR spectrum and hydroxyl groups at presence proton generates singlet at that 10.751 ppm, and that 313 NMR spectrum was shown here. At that 313 NMR spectrum of this hydroxyl group is present in the 164 ppm, and that the CN region of 39.2 in this region. And then single crystal X-ray diffraction is the another characterization is done by the Arthur diagram and packing diagrams are shown in the slide, and the single crystal X-ray diffraction is used and analyzed the size of the crystal. The crystals are orthorhombic space groups are involved. In this slide, denote the ABC is the 3 values are cell parameters, and that another characterization is the thermal analysis. The DG-DTA curve now revolves that thermally stable below 160 degrees Celsius and indicate by exothermic speed. And that another same morphology of the crystal is shown here. And the same images are used to describe morphology of the crystal surface and arrangement based on the image are shown in the slide also. Another characterization is done by the Mulligan atomic charge. This scale electronegativity explains intramolecular hydrogen bond between NH and OH in the Mulligan atomic charge of distribution in that one. And that finally, homologo beta
Come to
is
conclusion.
scale explains the chemical stability
Nivetha,
and
ma'am.
reactivity of the. Yes, sir.
Come to conclusion, madam.
Okay. And that summary and that the summarized findings of the work, and thank you.
Okay. Okay, thank you, thank you.
Thank you, sir.
Meena? Madam Meena available? Kannagi madam?
Yes, sir. Available, sir.
Kannagi madam, you can start your presentation.
Thank you, sir. But I could not display my screen, sir.
Okay, madam, you can start. No problem.
Okay, sir. Thank you, sir. Good evening to all. I am Kannagi from the Department of Chemistry, Thandai Periyar Government Arts and Science College. My topic is the evaluation of Rhinacanthus nassotus leaf extract as a green corrosion inhibitor for mild still in acidic environment, sir.
Introduction, sir. Corrosion inhibitor is a chemical substances that when added in a small concentration to a corrosive environment, reduces or prevents the deterioration of metals. In recent decades, synthetic corrosion such as organic and inorganic inhibitors are expensive and harmful to the environment. So I can choose the plant extract as a corrosion inhibitor. It's a green corrosion inhibitor. Because of plant extract contains phytochemicals that forms protective films on metal surface. My scope of the work is to extract the leaf constituents of Rhinacanthus nasudus plant to evaluate the inhibitory efficiency on mild steel in 1M hydrochloric acid using weight loss methods, and also analyze the surface morphological structure and functional groups present in the inhibitors on the mild steel using semi-image and FTIR. Experimental methods are, I was collected fresh leaves from our village, the ethanolic extract of plant extract, 10 gram of plant powder which was macerated with 100 ml of ethanol. The prepared plant extract has been used to reduce the rate of corrosion on mild steel. I can use the corrosion rate formula, sir, for weight loss method. From the weight loss method, the results are mild steel coupons reduce concentration of the inhibitor with the blank. This results indicates that a more corrosion takes place at lower concentration of the inhibitor. The inhibition efficiency of the plant extract increased to increasing the concentration of the inhibitor. Results of semi-image. I can choose the SEM results, sir. 3 kinds of semi-images, sir. First image is semi-image for polished mild steel and semi-image for mild steel with 1M hydrochloric acid, and also semi-image of mild steel with the plant extract. These 3 kinds of semi-image results are, first one image is Rhinacanthus nasudus leaf extract.
Madam, conclude your findings, madam, please.
Okay, sir. The conclusions are, the corrosion of mild steel in 1M hydrochloric acid solution is inhibited by the addition of Rhinacanthus nasudus leaves extract. The percentage of inhibition efficiency increases with increases of the inhibition concentration. The results obtained, the Rhinacanthus nasudus leaves extract is a good eco-friendly corrosion inhibitor for mild steel in 1M hydrochloric acid medium, sir. And it can be preferentially used to replace toxic and non-biodegradable inhibitor. So I can choose the plant as a green corrosion inhibitor, sir. Thank you, sir.
Okay, thank you.
Thanks.
On behalf of organizing team, I wish my special thanks to the chair, Dr. Munir Ahmad and Dr. Farooq Basa. And also I wish I wish to extend my gratitude to Dr. B.M. Praveen.
All the papers are very good presentations. I observed all the papers, but I didn't ask the questions. Okay, everyone has presented well. So I am expressing thanks for giving this opportunity, and congratulations to all the participants, those who have presented the paper. Very good amount of work, because of shortage of time, we have given very less time, even though they have given very wonderful presentation during the overall presentation. I am congratulating them, and I'm thankful for organizers for giving this opportunity, especially for Professor Syed. I am very thankful to him. Okay, all the best for all the organizers.
Thank you very much for your valuable time, sir. Thank you very much. Participants, on behalf of the organizing team, we extend our hearty wishes for your wonderful career and your nice presentation. Once again, I thank every one of you. Thank you very much.
Thank you.